Hello, good morning. Uh, Hi, jurors, everybody in this room and those joining us online. Welcome to Solar Decathlon India Finals 2024. And this is the Residential Cooling Retrofit Division. So the Residential Cooling Retrofit Division is this year's new edition in Solar Decathlon India. With a rapidly warming climate, cooling needs attention, especially in residences, which make up to 80% of the existing buildings in India. And this is a product development challenge. The teams in this division have made prototypes and they've tested them extensively to improve the cooling for everyone. The products must be easy to install and desirable for users. I'm very excited to welcome you all to the Residential Retrofit Division. My name is Amrit Raj MN and I'm the MC for today. So that means it is my job to keep everyone on time and on schedule. So that means interrupting you, the teams, as well as the jury members when you're giving comments. And I ask you to please be with me for the entire day. Our finalist teams have put in a lot of hard work. They've submitted their project reports about a month ago, and they've got their prototypes here with us today. So they will present their work to the jury. So teams, you have 20 minutes for your presentation, which is followed by a 10-minute Q&A. And then there will be a 5-minute break after that. So you must use these 5 minutes to take your prototype outside this room and allow the next team which is presenting to get their prototype inside. So the Residential Cooling Retrofit Division has 3 jury members, and they have expertise in product development, entrepreneurship, and cooling. We have Kshitij Sawant, who is a solution consultant with Sahaj Software Solutions. Hi, Kshitij. Welcome to SDI Finals. Next, we have Yash Shukla, who is the principal researcher and center head, Center for Advanced Research in Building Science and Energy, CRDF, at CEPT University. Hello, Yash. Welcome. And the third jury member is Himansha Singh. She's the co-founder at Crast. Hi, Himansha. Welcome to RCR Finals. So these jury members have had about 3 whole weeks, to review the reports that are submitted by the teams. And they have looked at your work in detail and have already assessed your entries for all the 10 contests. So teams, the presentation here today will help them to hear your narrative. And they will assess your presentation and your mastery over your solution through the Q&A sessions. And they may revise your scores based on what they hear from you today. I'm excited to meet the teams today, and I'm looking forward for your support. Jury members and the teams, please keep all your comments short and to the point, and also your answers too. So without further delay, let's start with the presentations. Our first presentation is from Team Resolution. Their product, okay, lot of enthusiasm, that's good. And I want to keep this up throughout the day, all right? Their product is named as Koala, the superhero of portable cooling. Wow, so this is, I guess, the origin story. Team Resolution, please. The presenters, request you to take the stage. Hello. Can you please open your presentation? Yeah. Could you please stand here? So, yeah, 1 second. So, this is your instructions, right? You have 20 minutes to present your work to the jury, all right? So at 15 minutes, I will ring a bell here, and you will not have a 21st minute. So which means at 20 minutes, I will stop you, and in case you don't stop, I will not stop ringing the bell, okay? All right. So after that, you have a 10-minute question answer session with the jury. Please keep your answers direct and to the point. All right, the stage is yours. And you have a visual timer here also, okay? Your time starts now.
A very good morning, respected jurors and everyone present here. I'm Manav, and with me is Akshad, Mayank, and Vaishnavi, and we are together presenting on behalf of Team Resolution. Together, as a team, we have fought a bit, brainstormed a bit, but prototyped a lot in order to present to you this product. Presenting to you Koala, your personal chill companion. Over the past few years, Indian newspapers have been flooded with headlines relating to the air conditioning loads and the demands which lead to the environmental concerns. But let us understand in 4 simple steps what exactly is leading to the rise in air conditioning loads in India. The rapid growth of urban population is leading to the rise in number of apartments, which in turn leads to an increased demand of residential cooling, and this leads to an increase in air conditioning loads. We have together studied and got an aim that with this product we want to reduce the cooling energy, and at the same time we want to aim a reduction in heat gain. On studying the electricity consumption in India, we got to know that cooling alone occupies about 39% of the total electricity consumption. We also studied various cities in India that consume the maximum energy and got to know that Mumbai is the largest power guzzler of electricity consumption, followed by cities like Kolkata and Delhi. Since Mumbai falls into a warm and humid climate zone, people in Mumbai usually prefer active cooling and cool themselves through various active cooling devices. But along with that, there are several other cities that also fall in the warm and humid climate region. And those cities become our expanded target market. Keeping Mumbai as our beachhead market, we have started to follow a systematic user research diagram through a double diamond process. In this process, we have aimed to go from point A to point B, and with that, we have taken 4 simple steps known as the 4 Ds for delivering a good product. Those 4 Ds are discover, define, develop, and deliver, wherein we have developed several rapid prototypes in order to bring to you and deliver this product, Koala. For studying the user demographics and user personas of people in Mumbai, we got to know that they're facing several problems with respect to the existing air cooling devices. These problems are installation hassles and additional fitting charges, hidden maintenance costs of air conditioners, a lot of heat entering into the rooms through windows, and they are unable to regulate the flow of air during their sleep. This also showed in them a need for a device which provides an instant air cooling and makes them feel comfortable. Some of the users also told us that they are facing problems with regards that they are not allowed to drill any holes into the interiors. People are having portable coolers already installed in their homes, but those coolers do not provide sufficient cooling. A lot of dust enters into their rooms and spoils the indoor air quality, which leads to breathing problems. And ACs have pipings visible inside the room that clearly spoils the aesthetics of the room. This also showed in them a need and desire for portable, energy-efficient device that they can cool themselves with. A lot of young people also told us that they would prefer a newer device with IoT controllable systems occupied within them. We also interviewed several architects, interior designers, and developers in order to know our stakeholders better and the problems they are facing. Several people highlighted the problems of outdoor units and the aesthetics of the buildings being spoiled due to it. Interior designers told us that the box piping spoils the interiors, and certain developers had problems with core cutting inside their homes. On interviewing several HVAC consultants, contractors, and repair people, they told us that the outdoor units and the maintenance that comes along with it in the Mumbai high-rises brings a risk of life to them.
So after an extensive user research, we summarized our key findings as per what the users want. So they said they want a cooling device that can be used into multiple rooms, ambient room temperature between 22 to 28 degrees Celsius, a cleaner indoor air quality, a good looking device, personalized cooling, and they wanted to block the heat that is entering into their rooms, to reduce the electricity bills, an easy and cheaper to maintain and install product. They mostly switch on their ACs during the night time, and they prefer assistance even if the product is DIYable. So based on this analysis, we brainstormed a solution to design a truly portable active cooling device, a heat blocking curtain, and Venturi effect to enhance the efficiency of the product. So first, let's walk through a typical AC refrigerant cycle, where in the indoor unit, the evaporator fan coil unit is cooling the room inside, and the condenser fan coil unit is dissipating the hot air outside into the atmosphere. So we thought, what could be a better heat absorbing medium than air, that is the atmosphere? But did you know that water is 832 times denser than air, and water has the specific heat capacity which is 4 times than that of the air? So we thought that, technically the water or a liquid medium is better heat absorbing medium than air. And because of its higher specific heat capacity, it can act as a thermal mass and store heat for longer than air and then dissipate it slowly. Hence, we thought of designing a liquid cooled system where now the heat is dissipated into the liquid. But after a point, the liquid will get hot, right? So we thought of incorporating another secondary system to cool this liquid mass, and the heat dissipated now through this system would be in slow and delayed manner and in smaller quantities like that of what happens in a refrigerator. Now all of this cycle we thought of combining into one single truly portable unit inside one system. And then this is how we designed the system of our product, which consists of two systems, one which is a liquid cooling system and an air cooling system. In the liquid cooling system, we're using a refrigerator compressor to cool the liquid mass through the evaporator coil. And in the air cooling system, we're using an AC compressor and a tube-in-tube condenser to cool the air through the evaporator coil. Now the heat exchange between these two systems is happening through a heat exchange cycle in tube-in-tube condenser and the liquid container. Now let's see how the system is assembled into our product, where in the liquid cooling system, we have a refrigerator compressor, the condenser coil, a two-headed strainer, the capillary tube, and an evaporator coil which is submerged into the liquid mass. And in the air cooling system, we have a AC compressor, the tube-in-tube condenser, the dryer, the two evaporator coils, and cross-flow fan giving a tangential flow out. And these are the technical diagrams for our product, where we have plans cut at various levels, one through a condenser coil which is placed right at the bottom, through the liquid tank and through the liquid mass, through the tube-in-tube condenser, and through the cross-flow fan and evaporator coil. Here our key component is the tube-in-tube heat exchanger and the thermal liquid mass, where the liquid is pumped into the tube-in-tube heat exchanger. Furthermore, we have tried to incorporate the concept of Venturi effect, which is a popular passive cooling strategy used in Rajasthani and Mughal architecture, using the same concept in the air inlet vents of the machine, where which would improve the efficiency of the cooling efficiency of the product. And for that, we have prototyped using a 5 centimeter thick jali. And for the heat insulating curtain, we have prototyped using an aluminum bubble wrap insulation, where the aluminum foil right at the outside would reflect the heat that is entering into the room, and the bubble wrap or the air gap between would insulate the heat that is entering into the room, thus retaining the indoor air temperature, and it would give a good head start to our product because it won't heat the room up. Now let's see how our product performs better in comparison to the existing cooling products, that is the split AC and the portable AC. Split ACs and portable ACs worked on an air-cooled system, whereas our product works on a liquid-cooled system and temporal heat dissipation. Split AC has two parts, which is the indoor unit and the outdoor unit. And portable ACs, even though it has all the components assembled in one unit, the exhaust hose that is connected to the window becomes the outdoor component to it. But our product, being a liquid-cooled system, has all the components assembled into its product, and there's no outdoor component here. The split ACs, because they are fixed into their location, have absolutely no portability, and portable ACs, because of its exhaust pipe connected to the window, have a restricted portability. But our product becomes a truly portable unit where it can be taken from any room to any place and switched into any switchboard. Split ACs and portable ACs have an instantaneous exchange of heat, where when it is cooling the room inside, at the same time it is dissipating the heat outside. But our product works on a temporal heat dissipation. The split ACs can only be installed by a technician, and portable ACs has the whole setup to the window that is required for the hose pipe, but our product is simply plug and play. Now let's see how the compatibility of a product into existing infrastructure, where typically most households have 15 to 25 ampere switchboards into various locations. So our product can be plugged into the living room, into a bedroom, and even into the kitchens. Now let's see how a product is performing into an existing scenario where, as the user said, they require cooling during the night time. The active system here becomes the air cooling system, which is throwing the cool air into the room, and the heat dissipated is being stored into a liquid container here. And during the daytime, when you're off to work and you don't require cooling, this is when the temporal heat dissipation starts during the non-working hours of the AC. And here the first system, which is the liquid cooling system, is recharging itself as it is dissipating the heat in slowly and delayed manner in smaller quantities. For this product, this was a prototype 1. And in the prototype 2, we achieved significant efficiency in terms of the components that we've used and in terms of space management.
Going to cooling performance, we have opted for a combined approach of reducing the cooling energy with the help of a cooling device and reducing the heat gain with the help of a heat insulating curtain. From our user research that we did in deliverable 1, 83% of the people like the temperatures to be from 22 to 28. That is also an energy efficient temperature range, and it also falls under the adaptive comfort level. These are the measuring instruments that we use for testing. We tested our prototype and a baseline, which is an AC, in 2 identical rooms of area 120 square feet, where the baseline, which is an AC, is of Voltas 1.5 ton compressor, and it is a 3-star rating, where we placed 1 data logger outside to measure the outside temperature and 1 in the center of the room. A similar setup is followed for the prototype case, where the heat insulating curtain is blocking the heat and our product is cooling the room further. For the testing process, we have tested the curtain and the product separately to get a clear idea of our efficiency of the machine as compared to the baseline case. Talking about the graph, this graph shows the temperature comparison between our product and the baseline case AC, where red shows the dry bulb temperature, blue is the prototype temperature, and yellow is the baseline temperature, where we have managed to reduce the temperature in the room by 6.3 degrees Celsius, and both the AC and our prototype was set up at 26 degrees Celsius. This graph shows the relative humidity comparison, which we have managed to achieve a 10.2% reduction from the outdoor temperature, from the outdoor relative humidity. Talking about the energy consumption of a machine, the red shows the energy consumed by the 1.5 ton AC, and the blue shows the energy consumed by our prototype to cool the air, where our machine takes 0.736 kilowatt an hour, and the energy consumed by the AC is 1.219 kilowatt an hour, where we are getting a 0.483 kilowatt an hour of reduction. To test the curtain against a normal curtain, we did a 24-hour measurement, where we initially dropped the room temperature to 24 as we wanted our curtains coldness retaining capacity. So by doing that, the graph shows that, and the average reduction, we have done a 3 degree Celsius. Talking about the features and co-benefits, our curtain is one of our main features, where it is blocking the heat and thus reducing the cooling energy load on the machine. HEPA filters are used to trap the pollutants of 0.3 microns. We have also integrated lighting into our prototype to set the mood in the room right. Our prototype can also act like a site table feature. We have designed a user interface for the seamless integration of IoT into our prototype. CO2 sensors are placed in the prototype to detect the CO2 levels inside the room. We have also designed a manual for the users for better understanding of our product, and a copy of the same would be provided to you after our presentation. The installation of the product is pretty simple. You order the koala, a seamless delivery of the box comes right at your doorstep. You just have to unbox it. It's a simple plug and play, and it is ready to use with the remote control. The temperatures can be adjusted from 20 to 28, and as it is a portable device, you could take Koala for a walk anywhere you go.
So many features, but how much does it cost? Coming to the financial feasibility of our product, we have chosen a value-based pricing and a cost-plus pricing for our product. Value-based pricing is the perceived value of the product by our customers, whereas the cost-plus pricing is our manufacturing cost plus certain desired profits. These are several features that come along with our product, and through a Google response survey, we have found out the approximate values that the people are willing to pay for it. Here, several graphs also show us that the perceived value of our product is anywhere between 60 to 70,000 rupees that is perceived by the customers. But on working out and analyzing the cost plus price, we are able to provide this at a cost of 45,500 rupees for the base variant. And this, we are trying to achieve certain kind of financial feasibility that is exactly for our target market.
Let's understand the market for business real quick. So the total market value of air conditioners in India is expected to hit $5 billion by 2025, with residential segment holding the major share, and as well as the room air conditioners segment holding the major share in the entire market revenue, amounting to 64.2%. So what is our target market? With this product, we actually aim to cater to all metropolitan and super metropolitan cities in hot and humid climate around the globe, starting with our beachhead market as Mumbai because of higher population density and growing demand for active cooling. Also, we did our user research here, so we have an understanding of what the user of metropolitan cities of today needs. To detail out the target user more, we are targeting a group of which ranges into middle and higher income group, who are homeowners as well as tenants. Now with the young population, there are more millennials and Gen Zs coming up into this segment, who prioritize personalized cooling, who prioritize flexibility and portability with any device they use, and they are ready to invest in newer technologies, and they expect value in return for the invested money. So with Koala, we definitely are providing value with cooling, since it is a truly portable, multifunctional, interactive and efficient cooling device. I'll just run through the slides of our achievements. So we are targeting an influential market. The tech that we have used is one of a kind in this category, which will be patented soon. We are a feasible product, a completely retrofittable product in any of our houses, in our rooms. And a robust GTM is also planned to make sure that we are a profitable company later on. We aim to impact positively over the environment by simply reducing the number of ACs per household by our portability feature. Also, 1 ton of Koala is sufficient to cool a room of that required a 1.5 ton conventional AC because of our liquid cooling system. So the liquid cooling system is of 1 ton. And also in ampere consumption, the range is lesser than the range in the conventional AC. So we have developed this product. We want everybody to use it, but we want people to remember the brand with the value that we bring into the lives. So our team will always be committed to enhance human well-being, prioritizing sustainability and user experience. The portable AC market is in the rise as well, 8.4% CAGR, which suggests that there is always a growing demand for portability in cooling devices. And these are the market players which are already working in this segment. So they are already successful in conventional AC. So what are we doing? We are providing directly what the user desires. So this green, highlighted in green, is our USP, which none of our competitors in any way is providing in today's AC market. There are these three, we will be available in 3 variants. Pro is IoT integration, smart controls, and Pro Max you will get an insulative curtain in box with the product. And a robust GTM is divided into 3 phases. We'll target first the homeowners, that is D2C, then B2B with real estate developers partnering with online and exhibition partners. And phase 3, we will go into localized markets, enhancing our distribution channel. And it's done, sir. Vision, last vision.
No, I'm sorry.
Okay, thank you.
Thank you. That's your time. That's your time. Thank you, Team Resolution. That was a fantastic presentation. We came in just under time. Close, very close. Yeah. So it's time for the Q&A presentation. Q&A with the jury. Yes, you will start. Microphone.
So thank you for the wonderful presentation. Going through 100 slides in 20 minutes is not easy. So thank you for all your hard work and a very good effort. I have a couple of questions that I want clarification. The energy savings that you are talking about is instantaneous. What is the savings if you consider the nighttime operation or when you are discharging? There will be energy consumption as well, because you have second system working. When you add that up, would that still be leading to energy saving? That's number one. Can I ask 3 questions very quickly and then you can answer it? Second question is, have you heard of a concept heat pump, which has a reversible cycle that can help you reduce your components by half by reversing the cycle as opposed to having a second cycle? Have you considered that? The third question I have is, how long will the system run? What's the size of your tank and what's the water temperature that it achieves when you are cooling? So is it reaching 40, 45 or 50? These are the 3 questions I have.
So talking about the energy efficiency of a machine, right now for cooling the air, we are lesser than the baseline case, which is an AC. But when we add the discharge temperature that you are talking about, the discharge of the heat dissipation, and we are cooling it further, so we have 0.5 kilowatt an hour per hour in that. So if you add both of this together, we are not yet in par with what the AC is using. But going into the future, we are planning to use different coolants or use different strategies of heat sink, so that
so am I right to understand that when you both add that up, it's more than the conventional AC? Is that correct?
It's right now more than the conventional AC.
Thank you.
Second question.
So second question was about the heat pumps, right?
Yes.
Yeah. So
have you considered using heat pumps?
Yeah. So we started with understanding various technologies like heat sinks, where we saw metal heat sinks that are there in the market. But till now we have not experimented with heat pump. But thank you for the feedback. We'll definitely look into it.
That will exactly reduce your system by half, the components by half.
Yes. Okay.
Okay.
Yeah. And the next question.
Yeah. So the water temperature, we are taking it down till 5 degrees. And after the heat is dissipated into the water, it goes up till 50. The coolant can take much larger than that, but right now for safety reasons we are shutting off the compressor when the water temperature reaches us 50.
So it's a very nice to use a thermal storage system with a conventional system, but that would have been a nice way to explain, and I would encourage you to think about alternate thermal storage systems. And a calculation of number of water quantity, the amount of quantity you would need, because you are looking for 10, 12, 14 hours of operations. And the water temperature would rise very high when you are talking about discharging very quickly, making your AC less and less efficient as it operates. So these are the things you may need to start thinking. You may not have to respond. I'm just saying for you to think about.
So just to answer your third question where you asked about the quantity of the water, we have used 60 liters of liquid right now into the tank. And for 1 hour, it's running efficient. Like we have just tested it for 1.5 hours for safer reasons. So it has been giving cooling efficiency, and it is rising up to 45 to 50 degrees right now.
Thank you.
Congrats team, that's commendable effort what you guys have done in the last 9 months. Excellent work. I think you're talking of this whole portability, and that's a very big need. I think you're addressing a right market, a right user need. So good find on that. I also like the fact that you're actually thinking of product extensions once you launch it in terms of Pro, Ultra, Max. I think that opens up a lot of business value to that. So that's a good thing. One question I have is, you all have built a lot of prototypes, and I'm assuming you've taken feedback from users or whoever it is, right? At what point, or what is that one key design decision that you all took to either pivot the way you all have designed or what you all are designing based on the feedback that you all have got to improve where it was before and now?
Yeah. So after a lot of prototyping, the major feedback that we have been receiving is that probably about the size of the unit and the portability, like how most efficiently we can make it as a portable device. So from the previous device, we have from the previous prototype, we have been trying to reduce the size extensively, and even in the future prototype, in the third prototype, we aim to reduce the size of the machine by using different components and reducing the sizes of the fans. And by 32%, we are trying to reduce the size of the machine. So this was a key feedback.
From the feedback, we realized that people are now more keen into getting into the IoT features and all of that. They will invest more if there is a competitor AC, and if I give more sensor features product, so they might want to shift to this new age technology and new age technology product. So that is why. So that is also one of the feedback that we got from the user, and so we segmented the product into 3 categories as well.
After publishing our ad onto the YouTube, we have already gotten a lot of orders for the product, and so people are very excited about our product. So yeah.
Excellent. Just another suggestion. I think, see if you all want to consider focusing on the core of the product, which is cooling, rather than bringing in the curtain, because that can, I mean, somebody can buy a different curtain and manage the heat there. It will also allow you to improvise your product. So just get your focus back onto it rather than doing multiple things. You can also maybe consider positioning this product as a night AC, right? Predominantly using it through the night, because that's currently a challenge that one of your users are facing. And so use it through the night, morning when people are not at home. That's when that heat can just be dissipated.
Yes, yeah, that is the suggestion. Yeah. Yes, thank you so much.
Well done, guys. It was a great presentation as well, and I love the visuals. I know Amrit is looking because the time is running out. So I'm going to keep it very short. So could you quickly touch upon 2 things? So one question I have here is, what was the time frame of your cooling performance testing? Because in one of your graphs, I saw that it sort of started to go up. I couldn't sort of understand. So was it, going up after a certain period of time that the cooling is not efficient? Could you comment on that? And the second question I have is, if you can just, quickly touch upon the finances. How did you come up with 45K? And if as an investor, I'm looking into this product, what is my ROI looking like? And what are my profit margins looking like here? So what is your, sales price and what is your costing?
Sorry, I just want to add to that question, because I think what you're building is fairly capital intensive, right? There's a lot of components, a lot of manufacturing assembly that needs to go in. So it'll be nice to understand what you're thinking on that front. Cost of the final product or what the buyer will pay for is one thing, but the proposition to actually get it to market in the hands of the consumer is another thing. So if you can elaborate a little bit on that.
And on that point, just I want to mention, before doing all this work, make clear your fundamentals, right? And if your product is not going to perform, which I see challenge the way it's designed, even if you use heat pump will reduce their cost. You will struggle, if not right now, few years down the line. I think your fundamentals needs to be strengthened in the product.
Right. So to answer the question about the cooling performance testing period, we have tested it for around an hour and a half, and about we can reach up till 20 if we set the temperature of our machine at 26, which comes under our 22 to 28 desired temperature. But if we reduce it down further, which is 22, 24, then we can use the machine for an hour. But if we set the temperature at 24, then we can use the machine for 2 hours. But for testing period, we wanted to show the comparison between the graph, and to compare it easily we have just given a 1 hour period of time in the graphs that's shown on the slides.
And talking about the finances of the product, you asked like how did we arrive at the 45,000? So as of now, because we are in the prototyping stage, the manufacturing cost was a bit higher, but and also that we have purchased all the components at a retail price or a wholesale price for now. But as we go into the manufacturing stage, and as we even transform the body from the entire metal body to the plastic body, or even an ABS body or something like that, we'll able to drastically reduce the cost and even the cost of our components. So that will kind of help us come to the
So
desired pricing.
have you actually considered all that volumetric economies in your financial model then?
Yes, ma'am. For the financial feasibility, we have given a detailed, like as of the prototype cost, and if we go into manufacturing, what would be the approximate pricing of the products. So we have given that in the detailed table diagram.
Because when you're looking for finding a volumetric costing, it is very important to know how much is the output going to be from your factory. You may say you're gonna make 100 units a month, but would you actually be able to? Is it really feasible? And depending on that, your costing and logistics and everything. So this is something. I mean, I'm not expecting you to have all the answers today, but this is something you guys can think about, through your roadmap when you're looking into it. Because if it's to be commercialized, it's very important to have your finances strong.
Definitely, ma'am. Definitely, we'll look into this. Thank you so much.
Thank you, jurors. So
add one thing about the cooling performance. So right now for testing, we were just running the compressor throughout for 1 hour or 1.5 hours. But when we add a cutoff system, the compressors will cut off in between and start, cut off in between and start. So that will prolong the working cycle of it as well. So that will also be added into the later system.
okay,
Thank you.
yeah, thank you, jurors. Thank you, team resolution.
Thank you, sir.
Yeah.
Thank you, ma'am. Ma'am and sir, if you can, whenever you get time, just look into our product. Thank you.
Thank you. Yeah, you can. Yeah. So we're just gonna take a 5-minute break now, and start with team 2. Good morning. Kindly request everybody to settle down. Hi. Ron, tell me when we go live. Live? Yeah. Moving on to the second presentation of the day, we have Team Arctic Air, and the product that you see before you, the name of the product is Mush Cool Panels, Mushrooms Be Cool. Team Arctic Air, kindly request you to take the stage. Team, hi. Hello, hi. So you will have 20 minutes to present your work to the jury. At the end of 15 minutes, I will ring a bell to let you know that 15 minutes are done. You will not have a 21st minute, which means at 20 minutes, I will stop you to end your presentation. After that, you have 10 minutes for a question answer session with the jury. Okay, the stage is yours and your time starts now.
Rising temperatures significantly impose high energy demands that could strain India's power grids. As air conditioning and groundwater pumping becomes a necessity during the scorching summer. What does summer remind you of? Ice creams, mangoes, but that's the positive side. How can we forget parched throats, sweaty skin, and often frequent power cuts? And well, of course, thermal discomfort. It also impacts the domestic budget on a whole. As per a CRISL report, summer heat can potentially strain India's already burdened power sector. In order to save India from another power crunch, we have come up with a solution that is independent of any electrical consumption. A very good morning and a warm welcome to all the respected jurors and the attendees. This is Team Arctic Air from the product division. We are absolutely delighted to have this opportunity of introducing our creation on this platform and are hoping to live up to your expectations. Our multifaceted team of architects, engineers, and product designers have approached the divisional proposal based on the problem definition and the product addressing them and layering down them based on the various contests laid down by STI. The approach and journey from D1 to the current product has been mapped as shown in the slide. It has undergone ideation, design concepts, which have all been a ceiling approach, followed by a modeling, both a simulation and physical scale models, shortlisting, validation, finalization, and finally, a product. The product we intend to bring to the market will not replace the conventional cooling devices. It would rather reduce the load on them. Moving on to the problem definition that we identified. 19.56% of the Indian urban population live in flat roof residences in hot and dry, warm and humid, and composite climatic zones. They belong to a middle income range of 7.5 LPA to 15 LPA and suffer from thermal discomfort through the heat transmission from the roof slab. Next, we chart down the potential of our product through value proposition and novelty. We look into the intermediate floor slabs and not our product's point of concentration. We have condensed the problem definition to be corely the roof slab in the uppermost floor. This pie chart states that it emphasizes on the maximum thermal comfort achievable with mush cool being retrofitted in homes. The schematic diagram on the right shows an interrelation between the parameters influencing the value proposition for the users. This is again a mapping of what the users want, what our panel offers, and how is the panel better. The users want, of course, an eco-friendly, low-cost, easily maintainable, and easy installation for the product they're looking forward to. The panel, of course, being an acro-based and natural product, it's independent of refrigerant use, as well as eco-friendly in nature. It's easy and low cost. It's an efficient insulating layer, thus cutting down the heat gain and the heat transmission from the topmost roof slab. Next up is the novelty. We look into the various aspects which starkly differences our product from other conventional and vegetative panels that are already available in the market, considering bagasse as one of the major things. It's modular in nature. As showcased here, our panels have been iterated through a lot of hit and trial procedures and in various sizes. The thickness and the module sizes are customizable based on the ceiling sizes of the residences. With lower thermal conductivity, it offers excellent insulation as in terms. It's 100% biodegradable and comes at a low cost of 94.1 rupees per panel.
So our target market for our product is strategically segmented into two primary categories: B2B, business to business, and B2C, business to consumer. Within the B2B segment, we are focusing on designers, architects, construction firms, and contractors. These professionals prioritize attributes such as scalability, performance, functionality, adherence to regulatory compliances, and sustainable practices. Conversely, B2C segment centers on meeting the demands of homeowners and building owners. Their key considerations are energy efficiency, cost effectiveness, sustainability, and aesthetics. Our end users comprises of individuals with flat roofs and have an annual income of 7 to 12 lakhs per annum, representing 19.56% of the urban population. To reach our target audience, we utilize two key channels, offline and online. Offline strategies include cultivating partnerships with vendors and contractors, enhancing public relations, hosting trade shows and conferences, and establishing a presence in material stores. Online, we will focus on content marketing and search engine marketing to engage and capture the audience in the digital sphere.
The identified users and stakeholders are homeowners, retrofit architects, and the government itself. Homeowners benefit from the easy DIY installation of 2 hours 45 minutes, also leading to temperature reduction of 1 to 3 degrees Celsius. The density of mycelium-based panels ranges from 275 to 325 kg per cubic meter. They offer good moisture resistance for day-to-day applications. Architects can appreciate the eco-friendly aspects of Mushcool. It's 100% biodegradable. From earthly hues to organic textures, mycelium panels sculpt spaces with nature's touch. Given its environmental benefits, Mushcool could be a candidate for government incentives. They also offer potential benefits of fire resistance. The panel also provides the following co-benefits. Noise is reduced by 5 to 15 decibels on average when compared to fiberglass. The indoor air quality of mycelium is less than 10 micrograms per meter cube, whereas for other conventional materials, it is 10 to 15 micrograms per meter cube. The flame spread index of the mycelium panel is 25 to 35. Lower values signify better results. Carbon sequestration of mycelium is comparable to that of a tree. 20 to 50 grams CO2 sequestrated per kg. The waste diverted for panel is 2 to 5 kg diverted per meter cube. The job creation is almost twice to that of traditional insulation. That is 2 to 4 jobs created for 2 rooms of 10 into 10 square feet, whereas it is 1 to 2 jobs created in traditional insulation. Aesthetic design possibilities. Modular and living walls create a space that fosters a warm and inviting environment. Natural pigments could also be used for the panels, which has a variety of options. The stakeholders involved are primarily consumers, designers, and the government itself, with different priorities for each category.
Next up, we quantify it through the cooling performance. First, we achieved a temperature difference of 1 to 3 degrees Celsius through a variety of tests. Our tests has been laid down through 4 different parameters. First is through the secondary research based on several research papers and literature study. Second is the model simulation that we did. Third, being the physical scale model on a scale of 1:10, where we had a module setup with AAC blocks being exposed in the sunlight for over 12 hours to see the temperature difference. These two pie charts above show the material composition of the panel and suggests a comparative study of energy consumed in manufacturing fans, coolers, ACs with respect to the Mushkool panel. Although we are not really competing with the cooling devices already present there, because ours is a vegetative panel and it has a competition with respect to the bagasse boards, which are available even at a lesser price. But it comes with a lot more core benefits. We have duly shown the R value calculation and the U value calculation, which clearly states that it is a very low thermal conductivity, which promises a very good insulation, thus bringing a temperature difference of 1 to 3 degrees Celsius. Next up are the tests that had been quantified through. First is the digital simulation model for a wedding. A digital simulation was conducted to assess the thermal performance of the retrofitted panel. So these two particular models show the module without the installation of the panel and the other one with the installation. Then we move up to the physical scale model, which sets up our base case and the experiment case. A 1:10 site, a residential module with AAC blocks has been with the specifications given in the chart on the bottom right corner, with the substrates and their binding capacities and U values respectively listed down. Next up, we move to the tools utilized that we used to lay down the various aspects further.
The installation process of our Mushkool panels is straightforward and requires minimal tools. You'll need a 3M dual lock fastener, a 3M sealant, and of course our Mushkool panels. Begin by preparing the sealing surface for the panels through gentle dusting and thorough cleaning with water spray and a mop. Next, meticulously affix the fastener to the ceiling, ensuring precise measurement. You need 3 fasteners per panel. Similarly, attach the fastener to the panel with precision. With the fasteners in place, apply the sealant to the panels, focusing on the areas in between the panels for a secure bond. Once this process is complete, proceed to mount the panels onto the sealing surface. This methodical approach ensures a professional and reliable installation, highlighting the simplicity of our Mushkool panel system.
Coming to technical feasibility, the manufacturing process, it's a five-step process. The first step, inoculation. It takes 2 weeks. We mix materials, sawdust, sugarcane bagasse with mushroom spawn to create base for our fungal growth. The second step, growth. It takes around 28 days. The mixture incubates in controlled environment, fostering mycelium development. The third step, break off. It takes around 3 to 4 days. The fungal activity is halted by drying or heating the colonized substrate. Fourth, pressing. It takes around 2 hours per panel. Materials compressed into molds to form desired panel shape and density. The last step, finishing. It takes around 1 hour per panel. Panels are finished, quality checked, and packaged. Scaling up. We have progressed from lab experiments, that is the phase 0, to producing small batches for testing. Phase 1, pilot production, installing a larger batch in a designated test house for real-world performance evaluation. We are currently at this phase, completely bootstrapped and supported by our institution. Phase 2, scaling up production. Partnerships and funding will help us expand production efficiently and sustainably. Phase 3, market expansion. Collaboration with distributors and builders will make these panels accessible to a wider audience. Coming to technical considerations, cost analysis for installing mycelium panels in an average middle income house covering 500 square feet reveals a promising initial cost of approximately rupees 5,500 for 125 panels. This cost breakdown is detailed in the table on the slide. While further optimization is ongoing, the initial figures suggest the potential for competitive pricing compared to traditional building materials, especially when considering the long-term sustainability and benefits of our panel. Our panels are technically sound and scalable solution for sustainable retrofit. Through ongoing research and collaboration, we are bringing this innovation to the forefront of building industry. Next. Coming to the financial feasibility, imagine naturally cooling your home while saving money. Our panels, made from materials like sawdust, sugarcane bagasse, and mushroom spawn, offer a groundbreaking solution. Here's why they are financially and ecologically sound. Cost-effective cooling. Initial cost sits around rupees 94 per panel, making them competitive. Low installation fees with the option for self-installation further reduces the cost. We can save up to rupees 7,200 on electricity bills by keeping your home cooler in summer, which comes to around reducing rupees 400 to 600 per month. Plus, minimal maintenance saves your time and money compared to the traditional options. Comparing our products with the traditional options or conventional options. While traditional underdeck insulation and suspended ceiling tiles range from 20 rupees to 100 rupees per square feet for materials, their installation cost can sum up to rupees 30 per square feet. Our panels offer a potentially lower overall cost compared to traditional or conventional in the residence like a fan or a cooler or an AC. Most cost-effective cooling options are Mushcool and Mushcool Plus fan with a total annual cost under rupees 3,000. These options also have a relatively low environmental impact. Conventional AC units are effective but come with a higher cost and CO2 emissions. Hence, combining Mushcool with a fan or a cooler offers a balance between cost, efficiency, and environmental impact.
So we are launching our panels as a sustainable building solution with a clear plan. First, we position our panels as a sustainable yet effective solution. To protect our innovation, we are seeking patents, trademarks, and confidentiality agreements with our stakeholders. We are starting with bootstrapping and strategic partnerships with industries to effectively manufacture the panels. Our pricing strategy is set at rupees 90 per panel with discounts for early adopters to quickly gain market traction. We're collaborating with key stakeholders like false ceiling vendors, contractors, and builders to target large-scale commercial projects. This B2B approach will help us establish a strong foothold in the false ceiling sector. Our marketing approach combines digital campaigns, trade show participation, and awareness programs to educate architects, designers, and homeowners about the benefits of Mushcool panels. We're seeking angel investors after 12 months to accelerate our growth. In year 2 to 3, we'll pursue seed funding to expand our market reach and invest in technological advancements. A key milestone is launching an online platform with AR/VR technology after 2 years. This immersive experience will showcase Mushcool panels' unique features, enhancing customer engagement and drive sales growth. In summary, our well-planned strategy with IP protection, key partnerships, creative marketing, and strategic funding will establish Mushcool panels as a leader in sustainable building solutions, providing the way for growth and industrial influence.
In conclusion, it's just that mycelium mimics the principles of regeneration. Thereby, it is literally a solution that is devoid of any movable parts, thus catering on the fact that it's simple and efficient. It makes a building more energy efficient, and doesn't bug the user in terms of electricity consumption or installation. At the end, users don't really need a perfect solution. They want a better solution, and Mushcool is in the right direction.
Thank you, Team Arctic Air. Well within the time. So now let's move on to the question from the jury. Himansha.
Well done, team, and interesting product. So one of the things that I think I had mentioned earlier as well, what are the mechanical properties of this, right? Because when you are putting something up on the ceiling, you're also, have bulbs fittings and fans and a lot of those other things. So what is the screw withdrawal? What is the MOR and MOE, which is something that you need to know when you are making panels, which basically relates to elasticity and rupture. So have you guys done any mechanical testings on these panels?
So as you asked about the installation at the ceiling level, it would sit underneath the roof slab. So we have two methods, majorly focusing on the DIY method, which has been demonstrated in the video, considering the sealants and the Velcro. Apart from that, the panels we have made and we have iterated, they're yet to undergo such tests, considering they're still at a bootstrapping stage. So this is more of a future establishment. But apart from that, we haven't considered any air gap. We are putting it exactly underneath the roof so that there's no insulation whatsoever. Yeah.
And sorry, just one more question here. And are you guys using any kind of glue or is it just pressed with the heat? So when you're scaling up, have you considered the thermal consumption it is going to be for manufacturing these kind of panels?
Noted. So the reason why we chose mycelium is to leverage its excellent insulating properties, and along with that, it's like its binding strength is notable. So anyways, the panel comes up to a flexural strength of 105 MPa. So the durability falls on a scale of 1 to 5, it falls at around 2.5 to 3 as of now. And as of the autoclaving machine, it has a high manufacturing capacity of about 20 panels in an hour. So the heat consumption is not that, it's just pressed, and the density increases with respect to the thermal conductivity.
Okay, good.
Good work, team. Very interesting approach you all have taken here compared to a standard conventional approach of building another appliance. It was nice to see those photographs in one of your presentation and your observation of how people are cooling some of the ceilings by pouring water or putting another roof over it, right? A tiled roof over it just to create that shade. And I also like the fact that you all are thinking about this whole B2B and B2C approach. Very nice. My question is actually pertaining to that. If you're saying B2B, what is the core value proposition for somebody in a B2B? Did you all go talk to anybody in that segment? I mean, I understand that you all have visited residences that could have inspired you to come up with the solution. But I think your solution is more suited for B2B than a B2C. The end user is the end customer, residential customer, I understand that.
Yeah, so we are starting with only B2B for the first 2 years, and when the online platform comes up, that's after the 24th month, that's when our B2C will start.
No, I get that. That's your step-by-step phased approach, right? Yeah. But did you meet anybody in the B2B segment to understand, see your value, they need to see the value. The end customer, you spoke about the value about cooling and everything, right? That's for the residential user. But what's in it for the B2B customer, the B2B segment? You got my question?
Yeah, definitely. So just because, I mean, we had come across all of these panels based on the different module sizes and everything. So we took a feedback from the residential and we stuck to like these panels being used in the residential upfront for now, but we haven't really investigated on the B2B sector, considering it's again like a future establishment to be.
Okay, because that is a suggestion I think you all should likely, because this has excellent application in commercial buildings rather than residential buildings. I know, I understand the problem is high on the residential, right? But the way you all are talking about going to B2B is the right approach I would take. Refine your product and then see what is suitable for the residential sector as well. Yeah. Okay. Good work, Pat.
So thank you for the presentation. It's a very important area. Thermal insulation, reducing the cooling need is very important. As important it is to develop the new solutions. I think I have 3 comments, not really questions. Comments are that you may need to do a lot more work on the material level. Some of the numbers of conductivity is not something that I would align with what you have said. I think I'm glad that you added a unit to R value in the presentation, which is very good. So you are moving in the right direction. But some of the equations and the U values are fundamentally needs to be looked at again. Your R values and U values are overestimating the benefit of the material. Basically, you can't have the overall product K value better than the component K values. And the thickness that we are talking about is 40 mm in some of the calculations. It's R values. You have used length as opposed to the thickness. So these are the things that needs to be looked at. So 2 elements that you can, I think there is a potential for you to look at. 2 things that you need to study is really gathering and working on the providing the insulation properties of material. Then the second point is you have given a wide range of density. Now conductivity has a direct relationship with the density, and you have mentioned U value without the densities, and it needs to be looked at. And when you have these products, you have to also work on the uniformity, because then only you get the repeatability of measurement. So one batch may be very good, other batch may not be very good. So those are the 3-4 areas that you may need to look into if you want to commercialize these products. But a lot of work needs to happen on the material science before you actually look at the other aspects. If you have anything to inform or react to that, let me know in terms of if my on the comment.
So obviously, just to add, this is the exact reason why we did not really show the thermal conductivity value of the panel as a whole, because we're still iterating on the material again, because we have had tried and tested other substrates, like a combination of substrates, which we refer to from various literature studies which have been established earlier, and they have actually shown good thermal insulation before. So initially it had failed, like using wheat straw as a substrate, but we had also put their value there. So
yeah, but I saw a slide showing your insulation K value is better than the EPS or the other insulation materials. That's misleading.
Got it.
Thank you. That's all, jury members.
Sir, for the insulation of EPS, all of that is being backed by secondary research papers. And
I'm not talking about the other materials, but the materials that you have developed, your comparison is questionable. You are saying that's backed by a secondary research, is what you are saying? Your material K value is well known by you? Have you studied it well?
No, so us using mycelium as an insulating material is like a new to age concept, because mycelium has always been used as a construction material, maybe to focus on the regeneration capability of this, or maybe it has been potentially used as a packaging material. So when we are putting it out, due to its, of course, a property of insulation, we haven't really, gone into the material substrates being more efficient with respect to the EPS. But then this is...
I'm just saying, not EPS as an example. Your comparison of EPS with the material composition you have would not lead to a similar... There is a lot of engineering that has gone in all these engineered material. Not True. EPS, XPS, or all the insulation. A lot of engineering has gone to reduce their, they improve their K value. And with the composition that you are showing, that seems to be challenging to achieve, even match, forget about better, but it seems challenging to achieve even the double of that. That's a very difficult problem to be solved. So I'd request you to look at that problem and re-verify your numbers that you are putting out there.
We'll do it. Thank you.
Thank you, jurors. Thank you, Team Arcticare. So we'll be taking a small 15-minute tea break at this time before we begin with the third teams. Tea is served right outside the hall. And folks online, stay tuned to support the other teams. Thank you. Hello everyone, welcome back from the break. We are going to continue with the Residential Cooling Retrofit Division presentations. The next presentation is from the third team, Team Navia. The product is named Bloom, Don't Sweat It. Team Navia, could you please take the stage? So team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a bell to let you know that you have 5 more minutes remaining. You will not have a 21st minute. I will stop you at the 20th minute if you have not completed. So after your presentation, you have a 10-minute question and answer session with the jury. Please keep your answers direct and to the point. Okay? And you have a visual timer here. Okay, so you ready? Yeah. All right, so as your slogan, don't sweat it. All right, your time starts now.
So what do we think when we think about cooling and how expensive it is? Well, we at Team Navia from Vishweshwaraya National Institute of Technology, Nagpur, along with our industry partner Vayujal Technologies Private Limited, which is based in Chennai, and our multifaceted interdisciplinary team, we have come up with a solution, an inexpensive solution to cooling. Bloom. It all starts in Chitaroli, a mohalla in Nagpur. Well, you'd wonder what is so special about it. Here, we see the Murtikars, right from the Gond dynasty, the people who lived here for a living. These are sculptors who were there from generations, but now, due to expenses, we can see how they are shifting to white-collar jobs. Now, if you see how we've documented Chitaroli, it is quite evident that towards the lower halves of the building or the lower stories, we can see the workshops of these murtikas. While due to urban intensification, we can see that there's vertical expansion that is happening and the residences are on the upper floors. So, due to the dense population of this particular mohalla, and also that the annual income ranges from 75,000 to 2 lakh rupees per annum, we saw a need for intervention. Apart from that, all age groups were seen over here, and also the occupation was seen as a seasonal or a traditional one. Team Navya saw that there was a need for intervention due to urban intensification and inadequate airflow, which is quite evident from the street section. Also, here in the video, you can see one of the houses. Here there's a shop up front and there's a residence behind. There's thermal unease caused. There's a greater window to wall ratio, especially to the facades which face the road. And economic parity is not seen. So you can see the windows that are present inside the houses. Team Navya also came up with several rapid prototypes which basically involved evaporative cooling as a concept, right from using materials like clay tiles, ropes, screens, etc.
The need for budget friendliness effectiveness, and replaceability was established in the community. Bloom is a cooling device that uses traditional cooling systems such as evaporative cooling and helps cool the community. It is costed at rupees 16,843 rupees. It aims to replace modern cooling devices like ACs, coolers, etc. The targets were achieved through the contest areas, which then allowed us to the targets were achieved through the contest areas, which allowed us to, which allowed Bloom to address the pain points of the users, which were high raising temperatures, poor ventilations, lack of spaces, and liability to HVAC systems. Why Chittorori? Chittorori is a very densely populated area which helps it to be best served as the product where we can install the product. Chittorori can be amplified and generalized as a typical Indian mohalla where the product can be installed, and also we will be able to study the study other areas in the country. The team had surveyed 4 different areas in Nagpur, which were the Sanjay Nagar slum, Mominpura, Chittorori, and CPWD quarters. Through these surveys, we concluded that the users need a solution that is easy to install, cost effective, and also cool, and also very cooling, which provides cooling. The customer profiling were based on the age, the occupancy, and the economic statuses of the people. The parameters of target market which we surveyed were age, salary, location, climatic type, and literacy rates. The feature of the product, we reviewed the customers, and according to them what feedback we got, we integrated some features like cost effectiveness, DIY product, no noise, etc. in our product. A study of the demographics of the 4 areas was conducted, which in which we increased in scale and showed how the product can be also applied in different cities of India with similar climatic conditions as Nagpur. The team led a comparative analysis of Bloom and an evaporative cooling technology product called the coolant, where we have pondered upon different points, where the Bloom basically is a window-based product. It consumes very less water than coolant. Both Bloom and coolant have use evaporative technology methods. Coolant, which is powered by Ant Studio, have recommended not to install their product in any residential buildings, while Bloom can be installed very easily, DIY friendliness, with the minimal assistance of a technician. Now, why would you choose Bloom over an ordinary fan, AC, or a cooler? Bloom is cost effective, easy to install, consumes less energy, and it also circulates fresh air inside the building, while ACs recirculates treated air and fans just circulate air inside the building. The possible limitations of Bloom may arise due to extreme weather conditions, faulty setup, and incorrect installation of the product. The novel aspects of Bloom are technologically it reduces the cost and dynamic working of the product. The Bloom has developed through an R&D process and simulative testing among the 5 prototypes which we developed in the beginning. It is a satellite inspired origami product.
The users need to have a streamlined design and competitive pricing, and also replaceable products which cater the maintenance were addressed. This was narrowed down further by exploring various localities in Nagpur, then documenting their cooling techniques, conceptualizing various ideas, also studying the market gap, market surveys, and various demo sessions and feedback sessions. Mr. Bajpai, where we installed Bloom. We interviewed him, and after the interview, we noticed that this family was dependent upon conventional cooling techniques and how they wanted an inexpensive and easy to operate solution, which Bloom stood. And Bloom also benefited with cooling and also gave them a healthier environment, and also cut down on their electricity bill. So through the feedbacks, we have noticed that the user wants a solution which is affordable. Also, should be it should not give odors which usually we get through the stagnant water tanks, and also it eliminates the need of periodic water changes. So with these feedbacks, we ensured that our product gives a instant cooling. It has a minimum handling. It is very easy to install, and it does not retain any water after the installation. We also asked various questions to the user. Is the problem solved through our features, and would they recommend this to others, and also was it user friendly?
Coming to cooling performance, so we installed the product at Mr. Bajpai's house and administered it for 3 particular parameters, that was temperature differential, relative humidity, and airflow rate. It was seen that the average difference that was found with the DBT and the baseline case was around 3.9 degrees Celsius, and the average difference between DBT and the product was about 1.5 degrees Celsius. This is confirmed from the thermal camera images that we have taken. Apart from that, the readings were taken for 14 consecutive days, out of which the odd number of days we have used for the baseline case and the even number of days we have used for the product case. So also simulative readings were done for the following, that is the daylight, glare, illuminance, and views. This was done for the product in its open state, closed state, and the collapsed state.
We installed this product for 4 months at 2 sites. One is the Chitroli, another is a conventional household at Nagpur. So this device is a very replacement to conventional grills, and then we also did various testing like light fastness test, weathering test, and fabric stiffness test, through which we also developed the product further. Then we have used the gear and chain mechanism, and to achieve the stiffness we have used cardboard in the flasher, and we can use also can material for a longer run.
So what product will provide me is easy installation, it is adaptive cooling, and also easily operatable. The team Navia has came up with the product Bloom. We have made 30 cm 30 cm flasher modules which are used to achieve scalability of on any size of windows. The Bloom is a very dynamic product. Even in its closed form, you have access to the windows. Your access to windows is not hindered in any way. And in open state, it acts as a protection, providing grills for the window. Let's look at some of the technical parts which are used in it. Aluminum extrusions form the frame for the structure of the entire product, and also there are many custom-made 3D printed parts which are integrated into the product, as per the design requirements. These are some of the 3D printed parts which are added there, and these are all the 3D printed parts plus the motor which is used for operating, making the flashes move automatically in the open and closed forms. Flasher is mostly made up of bamboo fabric. Why we using bamboo fabric is because bamboo fabric has the properties of naturally absorbing moisture from the atmosphere. It has higher water retention properties. It also it is also really strong and thin and perforated. Let's look at a scenario. If we set an ambient temperature of 22 degrees Celsius for a product, and if the product senses that the indoor temperature of the house is more than the ambient temperature set, it will automatically move from its closed form to its open state, and mist will be sprayed over it, resulting in evaporative cooling from the wind outside. And when the ambient temperature is reached inside, the flashes will move back to their initial state. This is the working of how the flashes move during the phase change. When bloom arrives at your doors, it will be in 4 pre-assembled parts. This means that there are 4 easy steps for assembling this product, which are mentioned in our pamphlet. This pamphlet also consists of all the parts which are in it, as well as the tools we'll be requiring, mostly an Allen key to join the things. We have installed our product at Chitaroli. The approximate time which it took us to install this product was about 15 minutes. This video represents all the joineries and things you will need to install the product. This table showcases all the specifications of the materials of the components which are used in the product. Why are we using PLA? Because it's really cheap, it's readily available, you can make customizable parts from it, and it is scalable to mass production. But it is also brittle and it can change its shape due to exposure of high temperature. That's why we are providing alternate method of production, being metal 3D printing or using another materials such as ABS or PETG. Why are we 3D printing these things? Because 3D printing will allow us to have it in mass production, make it precise. Also, it is affordable it makes it affordable for the product.
Talking about the cost of the product, here let's talk about unit economics. Considering one unit that will be put on one window, and the direct cost, that is the raw material that will be needed for the construction of the products, taken into consideration that everything is purchased on retail pricing, the cost that is achieved is 10,643. But however, if we add indirect costs such as sales and marketing, that is about 4,900, it accounts up to 15,543. But however, if we draw a profit margin of 8%, the total selling price per unit will be 18,786. Now, this would be cost-based pricing, but value-based pricing would be 3 times that of the single unit. The major stakeholders here would be the manufacturers or owners, the consumers, the suppliers or vendors, and also the advertising media. So value-based pricing is basically done in 5 stages, where the value assessment of the product is done and pricing strategy development is done. Now, if we have to do a risk mitigation assessment, we have to look at the production cost, which has to be lowered, and the selling price of the product should be taken care of. And we have to develop a demand in the market. So if you look at the short-term roadmap, that is 16 to 18 months to sell the product, the focus will be on the market validation and customer acquisition, which will basically be done by putting up a strong value proposition and implementing targeted marketing campaigns. And here the metrics that will be used will be customer acquisition cost and customer lifetime value to build a brand. In the long-term roadmap, we are looking at market expansion and profitability. This will usually be done to expand marketing by expanding distribution channels in new regions. And this will be done by using metrics such as market share, revenue growth, etc. So these are the unit economics projection that we have done for the short-term and long-term basis. So when we look at Bloom, it is a robust marketing plan should be put up to sell the product, and a demographic study should be carried out as to who will buy our product. So the age limit which we figured out was 25 to 65 years old with eco enthusiasts. And the ideal buyers will be families who are looking for cheaper cooling solutions. Now, the most important thing is, why is the product basically based on the price of 16,000? Like, if you can see in the market, we know that a traditional cooler will cost something less than 10,000 rupees, and AC start from a range of 30,000. So there is a pricing gap in the market to which we would want to focus on. So scaling strategies that we would do would be product diversification, user experience improvement, etc. So are there some existing products in the market which could actually give a competition? Well, they are, like electrochromatic window inserts, PV window blinds, but they do not work on the concept of evaporative cooling. So what are the channels which we would create? That would be in phases, basically from the product launch phase to the decline phase. I'm just going forward with the slide. So to do the risk mitigation, we have used Porter's 5-method forces to see what are the potential risks in the market if the product is being launched. Yeah, thank you.
Thank you, Team Navia. Over to the jury for the Q&A session.
Thank you for a great presentation and quite an innovative origami approach. So yeah, I think we all liked that. So just to quickly touch upon a couple of points here. So have you considered 3D costing in your scale-up model? So you know, I really appreciate how you've done your finances here, and you've sort of taken into consideration the tangible and the fixed assets here. But what about the 3D costing? How much would it be? And when you're scaling up, would it affect the costing? Can you bring down it from 16,000? Because if you're looking at the households that you have shown in the very beginning, I think 16,000 would not be very cost effective for them. So what are the plans, and are you thinking about it?
Regarding the first question about 3D printing, currently it is using 2.3 kgs of the filament. The filament is calculated per like 1 gram would printing a 1 gram would cost you like 12 rupees or something, as in such thing. So uske according you can calculate the price of that thing. Then
So just explain. Is it going to be cheaper moving on? I mean, I don't know the
like,
market rates for these.
Yeah. If like filament, if you are purchasing, it will be costlier. So that's why when you do it in manufacturing, they buy pallets of huge thing. They are not strings which are there used, but pallets thing. So they are really they are like quarter of the price which you get for the filament. They are really cheap. So mass producing will be a really like it will bring down the price really low.
But what about the 3D printer and the initial cost of installation? Would that be feasible?
That for the as far as the manufacturing part, setting up a 3D printing farm is not that hard. You can find a really cheap 3D printer which will give you really good quality of prints, and it as for a 3D printer, it can work for 24 hours. It won't matter. It can just continue printing 24 hours, day after day, day after day, day after day.
Actually, matter of fact, the thing that you can see here, it was printed on the 3D printer that was made by him. So it was a very in-house thing that was made by us.
Lovely. Just one quick question before I give. What about the cleanliness and the maintenance of this? Because if it is against the window, and you mentioned that you do utilize the wind power, and what happens when there is, very high wind pressure? What happens when there is a lot of dust, because the multi cars will have a lot of dust in their households? How would it affect the maintenance of this?
Okay, to answer that, firstly, the flashers should be replaced at least once in 6 months. So that would actually be a potential drawback of the product as well. But we've also suggested the use of can. So what happens is, like you suggested, the Murtikas will be using it, right? So here we see the dust rises, but here the space is getting humidified. So with that, the dust settles down. So I think somewhere it's solving their problems as well.
Okay, I'll let the other judges know. Thank you so much.
Thank you, ma'am.
So good work. I think you need a lot of courage to attempt what you all have done, and the market or the Chitroli district that you all are trying to target. It's very difficult. It's much slightly easier to do something in an apartment, but what you all are trying. So +1 hats off to even attempting something like that. Have you all thought about how big the market is? I know you all spoke about these 4 districts in Nagpur. But if one investor has to, invest in something like this, how big is this? Any thoughts on that?
So actually, if we have to consider concepts which are based on evaporative cooling, as of now in the market, as we compare to coolant stands as one example, as of now the market is not completely evaluated as well. It's a concept which is still evolving, and it is based on vernacular architecture. So we actually can't comment as to how it is put out there, because even here we saw people are using wet screens and things like that in many areas. Like in Rajasthan also, you can consider it as an example. So as of now, the market still has to be evolving out there.
Okay. My second one is, how did you come up with this particular size? This is a working model, right?
Right.
Can you operate it manually? It's also fine. Want to see that, how it works. So while the person is doing that, I'll just continue with the question as well. Did you do any sizing of the window and the opening? Any study around that, the different sizes?
Yes, we did. This was a very generalized size. This is of size 1 into 1.2 meters. So this was actually customized according to Mr. Bajpayee's house. But eventually, we also saw that this could be installed at our college as well. So these are some generalized size of windows, but however, this can be customized.
Okay, because for the video that you showed, right? You showed that lady showing that small little window. There are different sizes.
Yes.
Because this is a very informal construction.
Yes.
Right. So you will never have a standard size. And you're talking of pricing of 16K per unit. Let's assume this size 1 by 1 or 1.2, right? And the minute you have a window opening of 1 by 2, which is like a longish, it's going to double up.
Are you like telling me there are like number of windows? So
no, the unit cost of this, something like this, if I were to install it and I have an opening of 1 meter by 2 meter, right, or a random size,
yes,
16K I would consider maybe will go up to 1.5x at least for me to install, right? So I think it's worth spending a little time and understanding all the different opening sizes for the market on the segment that you're going after, and then trying to optimize. Sorry, can I ask one last question? Why those 9 flashers? Why not 4? How did you decide on these?
We actually wanted to make a module out of it, but I think it is a better.
As for the size, it is like 30 centimeter by 30 centimeter, because almost all the window size are in dimension of in multiples of 3 basically. You can see it will be at least 0.9, 1.2, 1.5. And also for the height is also 0.9 at this thing. So uske wajah se we thought to take it in 0.3 by 0.3 ka isme, so it will be scalable to almost any window.
Last suggestion, I think you should look into the cultural relevance of this product, especially for the areas that you're trying to fit it in.
Okay. Yes, sir.
Thank you. First of all, very nice novel approach. I have one clarification questions and then comments. So the water source, you will have to pipe it in here, or are you thinking to manually pour in the water there?
It will be manual pouring.
On the top, like you were doing in the right now.
There will be a top part. This will be filled with water. These are the mist sprayers. This mist sprayers is like they operate on vibrating molecules through space. So it will just force the particle moisture. It will force moisture through it, not a regular mist spray that just sprays water.
Second clarification question: are you thinking it as additional layer on top of glass or any other material, or are you just targeting only the windows which are completely open, like a semi-open spaces and things like that?
So here to answer this question, this particular product can be installed on the outside of like this the facade facing as well as the inside. But let's say the house is on the ground floor. You have access to the window, or maybe it's on the balcony, you have access. But what if it has to be installed maybe on a high rise? You wouldn't have access to the outside. So you can install it on yourself from within.
I'm just asking, is it a second layer on top of the
Yes, on the
glass, or are
frame.
you only talking about the, um, so this is on top of a glass that will come?
No, it can be installed on an existing window frame. So this will be a second frame to your window.
So great. Thank you for clarifying those things, because those are critical elements in terms of the installation and planning. Technically, I have several comments. One is, the direction will make a huge difference.
Yes.
The orientation, natural ventilation, dense population, the air movement is dense, urban community, you will have a very low air movement passing in. Relying on natural ventilation to provide evaporative cooling, the further the efficacy may go down. So you might have to think about the ways. So compare it with not traditional evaporative coolers or AC, but the traditional the huts that the people put in and pour the water manually, because you also have a manual system. How is this effective compared to that? That would help the product to be refined. Second point is, I think there are several questions in terms of the material usage of metal in here that you may need to reconsider using. The third last point I want to make, and you can, I have asked Amrit to give me 1 more minute so you can respond to that. This is where you are trying, I think you are doing a multi-objective optimization. You're talking about daylight, you are talking about air cleaning, you are talking about cooling, you are talking about affordable, then also integrating IoT into it, which may not be the focus area of an affordable segment. So you can look at modules, like, and things like that.
Yeah.
But I think it may be helpful to streamline your objective and then actually adding a value proposition, as opposed to trying to do everything, because you can't have one medicine that can have your stomachache and your headache and everything can be solved with that. So you need to prioritize and then rethink and rehash some of these, and you can respond in 30 seconds that you have, if you have any comments on these.
So thank you so much actually for pointing out. Like you told, we actually had to modulate up into the manual operation one, the semi-automated and the automated one. So for now we have gotten the manually operated one. So yes, we do plan on improvising it into the automated ones.
As for the cost part, the majority of the cost is going into the stainless steel rods. So like almost half.
I'm not talking about cost at all. He covered that. I'm only talking about the efficiency. So I'm talking about the metal leads to higher conductivity. Do you really need that much modulation? Do you really need that much opening? Do you need to cover all that? Why would not I have a shade and something with water spraying on that, which provides the traditional grass material that can provide me cooling with a similar effect? So these are the comparisons that you may want to make. We can talk later after 4 o'clock on that, but I just want to kind of bring it to your thought that you need to reconsider all that. But great work overall. Good
Yes,
job.
sir. Okay. Thank you, sir.
Thank you. Thank you so much, Team Navia. Yeah, we're going to take a small 5-minute break before we begin with the fourth presentation. So welcome back. Yeah. uh, we're going ahead with the fourth presentation in the RCR division. They have worked on sustainable blinds retrofit solutions called Sustainer Shades. So Team Swastia, please welcome. Please take the stage, yeah. Hi. Team. So you will have 20 minutes to present your presentation to the jury. At the 15th minute, I will ring a bell to indicate that you have 5 minutes left. You will not have a 20th minute. So if you have not done, I will stop the presentation. Okay. After that, you have 10 minutes as a question answer session with the jury. All right. So your time starts now.
Yeah, good afternoon, jury members of Solar Decathlon 2024, faculty members and everyone here. We are third year students of Sri Venkateshwara College of Architecture, Hyderabad, collaborated with BVRIT Narsapur, and we with our faculty members and our industrial partner Raj sir, we are here and we have achieved our innovative product today. These are our guidelines. And all these are my teammates. Yeah, where it comes to ours is an RCR Residential Cooling Retrofit Challenge under product division. So first, to take an overview of all products which are already net zero products for residents. So we went for case studies and all research processes, and our initial stage we have visited IGBC, and later our whole team have been worked for ideation of product. We came up with many brainstorming ideas. At last, we have came up with window blinds, our product Sustainer Shades, which have made with sugarcane bagasse. And at this stage, we have went through all manufacturing process, ideas, iterations, and compositions. And now we began our manufacturing process. Here at this stage, we have tried with many iterations and compositions. Simultaneously, we have started conducting text and marketing survey. Here in this survey, we have compared our product with many similar products in this market. And finally, we have achieved our desired product here. Introducing Sustainer Shades. Here, Sustainer Shades, it's totally different from many other curtains, where curtains only blocks the light, but where here our Sustainer Shades also enhances the cooling temperature at every residence by approx 4 degrees temperature, and also it's a dermat resistant, where this innovative approach also gives aesthetics and also health beneficiary. And here are materials we have used: sugarcane bagasse, paper pulp, fenugreek seeds, flax seeds, lemongrass, scented roots. And where it comes to sourcing of all these eco-friendly products, we really care our environment. So we always try to source ethically, and our products are all renewable and recyclable, especially where it comes to sugarcane bagasse and paper pulp. And as I have said at starting, ours is an eco-friendly product, and we have totally done with environmental commitment. Benefits of materials. It comes to sugarcane bagasse, we have using the waste minimization and utilizing the sugarcane byproduct. paper pulp. It reduces landfill waste and provides robustness on land. Fenugreek seeds, it's an energy efficiency product which we can use. Where it comes to flax seeds, it's a low environmental impact and very biodegradable material for our product. And lemongrass, it improves air quality and aromatic benefits from this. Scented roots, it reduces and stress and it's a sustainable sourcing for us.
Next comes the manufacturing process. So now let's explore the manufacturing process of our eco-friendly product, Sustaina Sheets. As we discussed earlier, Sustaina Sheets are the blinds which are manufactured from natural materials, primarily sugarcane bagasse and paper pulp. So primarily in the first stage, we began collecting sugarcane bagasse and waste paper. These are locally sourced to reduce the environmental footprint. We began by collecting the sugarcane bagasse, which is the byproduct of sugarcane processing, and waste paper. We then finely chopped the sugarcane pieces and then ground it. We boiled in different stages to soften the fibers. Then simultaneously we soaked the paper and then ground it. Also we have considered few other materials like fenugreek, flax seeds, lemongrass, scented roots. All these are also ground and soaked in water, which is crucial for the next step. Now when coming to the preparation, before preparation we already decided the composition meticulously so that our material, our blinds composition is same throughout. And all these materials which are soaked are mixed using an industrial stirrer. We then gradually added water to maintain the whole consistency. Next is the molding process. For the molding process, we have prepared a special mesh which is placed in a box, and this whole box is dipped in a container filled with water. So we then poured the blended mixture on top of the mesh so that it forms a rectangle shape. We allowed the water to drain, and then initial shape of the blind is formed. We let the blind dry under the sun. Before that, we placed a cloth on top of it so that we can invert it on the hard surface to get the shape we desired. Later in the drying process, after it is dried under the sun, we compressed it to the required thickness and cut it to the required length. Next is the SWOT analysis. This will be explained by Jhansi.
So coming to the strengths of the Sustaina shades, these are made up of the sustainable materials which minimizes the environmental impacts, and it increases the cooling performance by reducing the indoor air temperatures. And coming to the aesthetic appearance, it provides an aesthetic appearance wherever the place it takes. And coming to the aromatic benefits, as we added the scented roots to it, it has the aromatic advantages compared to that of the traditional materials. And coming to its weaknesses, its production scale, as it is a new product, scaling to the large scale to meet large scale orders might be challenging. And in market penetration, these shades may struggle with the brand recognition and as well as the customer trust initially. It provides opportunities like growing eco-conscious marketing, like it increases the awareness of the environmental issues, and as well as it can promote the consumers to buy the eco-friendly materials. If we look into the innovation potential, like it enhances the continuous development in manufacturing of the eco-friendly materials, and it enhances the product performance and the appeal. Its basic threats are the competition, like the established competitors in the shading industry with more resources might develop these alternative renewable materials, and in economic factors, economic downturns which affects the purchasing power of the consumers for purchasing their sustainable home improvement products.
Now let's see how Sustaina shades meet all the 10 contests. Value proposition, novelty, target market, user desirability, co-benefits, cooling performance, ease of installation, technical feasibility, financial feasibility, and go-to-market strategy. When looking at the value proposition, so Sustaina shades offer a compelling value proposition to meet the diverse needs of the consumers. So with the sustainability, effectiveness, aesthetic appeal, and cooling performance. When considering sustainability, already we have discussed about the materials and their benefits to the environment. So they provide a lot of creates an environmental impact. Apart from that sustainability, Sustaina sheets excels in durability and performance as well. The use of materials and colors provides a harmonious environment with the surroundings. When coming to the cooling performance, we have used scented roots and lemongrass, which actually gives the natural cooling and enhances the comfort. Also, we also do not use the electricity much, so there will be energy savings as well. When it comes to the novelty, in market, Sustaina shade stands as a novel product because of the innovative blend of materials and thoughtful design. These materials are eco-friendly and they enhance the performance. And Sustaina shades also enhances the aesthetics of the interior spaces. Next is the target market. Sustaina shades mostly target people who care deeply about the environment, who mainly focus on the sustainability, eco-friendly, who wants to use the products which are made of natural resources. Mostly the eco-conscious, we targeted eco-conscious individuals because they will benefit with our product, like they feel comfort within the product environment. Next is the user desirability.
In the in the user desirability, first we'll look at how it's done. Firstly, Sustaina shades has a high value of user desirability, where people who care about the environment actually come to the Sustaina shades. Let's look at how what are the factors of main user desirability. There are three factors: sustainability, usability, and aesthetic appearance. In the sustainability, people who are actually environment conscious are actually drawn towards Sustaina shades because of its all sustainable materials and eco-friendly manufacturing processes. Coming to the usability, Sustaina shades gives a ease of installation as well as ease of maintenance. It's very easy to remove and put on slats according to the lifeline of the product. And coming to the aesthetic appearance, we use earth tones to the product so that when it is placed in an indoor, the product actually seems to blend into the indoor spaces very nicely. Coming to the feedback and testimonials, the feedback of the users that we have already used have a very positive response. The positive response highlights the air quality difference, the air quality difference, the effectiveness of the product, as well as the durability of the product. These are the graphs that we have taken during the tests and the user reviews. Coming to the core benefits, first one is the improved air quality. Due to the ingredients that we've used in the product, like lemongrass, scented roots, fenugreek seeds, etc., the the air that passes through and enters the building is actually purified a little bit, and the indoor air quality improves. coming to the reduced carbon footprint, but during the production of the product, when compared to other products in the market, this product actually has very less carbon emission emitted at the time of the manufacturing. And when placed in the building, the whole net carbon emission of carbon footprint of the building is actually reduced. Potential of recycling and reusing. This product can be reused and decomposed if necessary. The reuse of the product is done as desired. When the product lifeline is finished, the product can be reused and made into a blend and then again molded and can be reused. The cost efficiency of when that happens is actually less, so the cost eventually decreases to the product. Coming to the cooling performance of the product, we've actually tested the product in various spaces and various rooms. We've gained a 4 degrees plus temperature difference in this when compared to the baseline product and the actual Sustaina shades. These are the graphs indicating the product temperature differences during different circumstances. And coming next.
So if we look into the ease of installation, like it consists of the simplified mounting process in which the blinds are already been strung and the slats are already pre-positioned such that it makes the ease of installation, and it consists of the step-by-step instruction process which makes the installer through the entire process, from the unpacking of the blinds to the last enter. And in user-friendly operation, it consists of the string mechanism. Each blind is equipped with the string mechanism which facilitates for raising and the lowering, and it engineered with the smooth operation. And in maintenance and support, it comprises of the low maintenance materials, like we have chosen the high quality sugarcane bagasse and durable paper pulp, which enhances the cooling performance. And in customer support, Sustaina Shades provides the comprehensive customer service which includes the customer hotline and online live chats, etc. And next, if we look in technical feasibility, in research and the development process, it comprises of the material research, testing and procurement, prototyping and iterative refinement, where the materials are selected with the specific benefits, and testing is done under laboratory for the material properties and the durability. In prototyping and continuous testing is done to optimize, to obtain the cooling performance better. In practicality of the material integration, we have done the innovative techniques for the installation process, and the field testing is carried out in the households also. In conclusion, Sustaina Shades meets the high standards in the market. And if you look into the financial feasibility, its key factors are the initial cost. The initial cost for the product are the material in the manufacturing process, and for the installation process. These long-term savings are it reduces the energy consumption, and as well as it reduces the electricity bills by reducing the air conditioning systems. And if you look into the cost analysis benefits, it comprises of the direct benefits, which includes the reduction of the electricity bills, and indirect benefits, it improves the market, market value, etc.
Where it comes to go-to-market strategy, we would really like to get our product into the market. And even before getting our product into the market, we want to get promotion of our product, like digital marketing, sales strategy, distribution channels. Where it comes to digital marketing, we want to launch a new website, and we want to get in social media, and also content marketing. We want to perform in trade shows and exhibitions. Where it comes to sales strategy, we even want to do direct sales or else distribution partnerships. Where it comes to direct sales, we directly want to get in contact with architectural firms, builders, and whoever are interested in this field. And also online sales platforms, channel partnerships. Where it comes to distribution channels, direct to customer and B2B sales. And as I have said, we want to get this product into the market. I think everyone are aware of this Green Pro certificate, and according to the guidelines of this Green Pro certificates, we are really eligible for this in every aspect, such as sustainable materials and energy efficiency, waste management, environmental impact, health and safety, product stewardship. And finally it comes to the conclusion we want to show our product. Yeah, actually our product is like, if we sprinkle water on this product, it may change temperature up to 4 degrees Celsius, and also it enhances the aromatic in indoor air. So few people may ask that why we have to sprinkle manually every time. Even we were working on this automatic sprinkling system. We'll get back to into this very soon. So we want to arrange a bottle here, and from this we want to keep some pipe like structure and attach some nozzles over here, and we were trying on this automatic sprinkling system too. Thank you.
All right. Thank you, Team Swastia.
Thank you.
And that is your time. So, on time. Thank you. Over to the jury. Kshitij.
Interesting attempt with using all the materials you all are trying to explore. Quite intriguing, and you all have actually built a product. It's an interesting product that you all have built with lemongrass and flax seeds and all. Good thought process. I have two questions. In your report that you all had submitted, you all are talking about somebody who's environmentally conscious customer, right? While I'm aware that there is a growing segment, can you talk a little bit more about that particular segment? It's a very niche segment.
Okay.
Like most people will put in the regular blinds, but I think what you all are offering is to a very niche audience who is environmental conscious, is aware of some of these factors that you all are talking about. There is a cost factor to it. There is a particular aesthetic look and feel to it, which I don't think may go in with the person's sensibilities, right? So it's a very small segment you're talking about. Can you elaborate a little bit more on some of the trends on that?
Yeah, okay. Actually, where it comes to curtains or else shades, each and every curtain almost represents a shade or else blocking a sunlight and etc. But where it comes to our blind, it also blocks the light and it also gives us air quality. It's not only like environmental conscious, even whoever people want, they can use this, as this is of same cost where it comes to each and every textile fabric curtains.
Okay. And you say this, you get 4 degrees lesser by using this. What is your baseline that you're using? Curtain. If I were to put regular blinds, what is the difference between a regular blind and this blind?
Regular blind is all about 2.5
degrees difference.
Yeah.
So effectively it's 2 degrees or 2.5 degrees, right?
Yeah.
Okay. Okay, cool. Thank you.
Yeah, good work, and really like your thought process, because we've had these kind of roll-up curtains, but introducing these materials, so well done on how you guys were thinking about it. So just building on what Kshitij was just mentioning, so you mentioned 4 degrees achieved, and what was the size of your room where the cooling test was performed? And say for instance, if it's a bigger area, would you need more curtains? Did you think about these things, the size and everything?
Yeah, it's 4x5 room. So we have window at two sides, south and west. We have installed in that room.
So two sides you had installed in. Okay. And what about the mold or fire resistance? Because this has paper pulp in it, for instance.
Yeah,
and
where it comes to window curtains, each and every curtain is not fire resistant.
Yeah, no, that's true. So
Yeah.
I mean, I was wondering if you guys have thought about it with health and safety perspective as well.
Yeah.
Okay. And so one more thing. So have you guys heard about honeycomb shades, earth shades, bamboo shades?
Yeah, yes.
How do you guys compete with them or compare? What is your differentiation?
Yeah, our differentiation is like indoor air quality improvement.
And has there been data to back that up?
Yeah, we have data.
Can you show? So what was the quality and how were you, what were the, oh nice, lovely. Okay. And this is achieved due to use of lemongrass. Is
Yeah,
that what
lemongrass,
yeah.
scented roots.
Scented roots. Okay. I've taken a lot of time, but just one last question, if that's okay. Yeah. Yeah. So once I've asked the question, so one more thing. So in your, what would have really helped us if you had also sort of explained the direct costings and indirect costing you've mentioned, the financials and, what could be done, but those kind of data would be nice. For instance, how much does it cost?
Okay.
And how did you come to that conclusion?
We actually made a table where we came across all the elements that we used and everything that we have done in the industry. We tallied all those and we've come up with the number of blinds that we can do in a in a certain time, and the cost that could actually get to be done for one blind.
So, it would be helpful if you were to show that table and, sort of gone through that, because the kind of raw materials that are being used is also difficult to source. So how would you look for scalability? There are a couple of, things, and this is not a question again, this is something that you guys can think about, using bagasse and where you can find bagasse and where you can have lemongrass. Thank you. So think about the raw material sourcing, think about how you're going to scale up and, how you could further reduce the costing, right? Okay, thank you guys.
About reducing the costing, we actually thought that when these things are recycled again, when we reuse them again, we can actually reduce the cost because the actual production thing is already here, the materials is already here. As many times as we reuse the same slats, we can again reduce the costings of it as well.
So 2-3 questions. First is, have you thought about external shading system instead of internal shading system?
Yeah.
If not, I would encourage you to look at the external shading system is technically much more beneficially than the internal shading system, but that has aesthetics, longevity, all that elements that you have to look at. Second thing is, I do have a questions with some of the numbers like 4 and 2.5 degrees you're mentioning. It's questionable because the material composition does not show anything which indicates that why that one shade would be different than the other. If you are talking about bamboo or other elements, they are equally beneficial. So I'll state all my 3 points and then you can respond whatever you want to or take it as a comment. Second, indoor air quality, again, the parameters as measurement does not show that it is an impact of lemongrass. And these are just a measurement. It's like I can show this room has a good indoor air quality, doesn't mean it's happening because of the shade. And so what is that element which is bringing indoor air quality? It's a huge claim to say that it improves indoor air quality and on a very, shallow assumptions. So I would really be careful in stating something that large based on, just the measurements, because outdoor air quality could equally be good and so indoor air quality could be good, right? I mean, you have to show the difference and things like that. So as a student, I know you're still learning, so I'm happy that you are recognizing the importance of it, but I would question if really this can make an impact on the indoor air quality. The third point that I wanted to ask you about is when you thought about these innovations in the materials, was it all based on the traditional materials or have you really considered any other factors in selection of those materials? So these are the 3 main things that I want to. So second point, I want to reiterate that, be very careful when you are saying it's energy efficient. It's actually comfort is what gets affected. Heat is already inside. And so you have to be, thinking like that. So I'll repeat the question very quickly. What is the difference that is causing that poor in 2.5 degrees, do you know? Is there something in the element which indicates that this can improve the indoor air quality? And the third would be, you know, these numbers that you are talking about.
Yeah, where it comes to any element which you are prioritizing, we have used aloe vera, fenugreek, lemongrass and scented roots, as all of these four materials has properties of cooling. So this has improved. And even sugarcane bagasse has improved this, like same cooler mechanism. If we sprinkle water over that.
So when you say it has a properties of cooling, cooling is not a property. Cooling is a result of a. So are you talking about conductivity, better conductivity? Are you talking about, you know? So I think I would recommend you to go one step further and actually looking at the properties that affects the cooling. It may affect the cooling, I'm not questioning it, but have to go deeper into that. You wanted to say something?
No, I think you covered it. I had another point. Yeah. I think you all have come this far. It's good that you all have a product here. I wish you all would have included a bit more details and gone 1 or 2 levels deeper on financial feasibility and GTM. I know you all spoke about different topics that you all are thinking about, but what about them, right? What are you going to do and what are you not going to do? Because when you talk about strategy, right, it's important. It's good to know that you're not going to do this and you're going to do this and why you're going to do this. Given the segment and given the product that you all have, how are you actually going to get to market? It would have been helpful if you all actually went a little deeper on that.
So actually we have mentioned this cost feasibility in D4, but we haven't here. And this is our...
We were just discussing about that. There are a few areas that you need to look into. The approach, I think you'll need to consider how you have done that costing, right? While you've considered unit costing of 1, but the financial feasibility, it's to do with bulk costing, right? And manufacturing. There are a lot of aspects about it that are completely missing. Rental, operations, various aspects. I know you all have put in some 1.51 lakhs or something like that. Which I don't think is the right way of doing it, but then I know you all are thinking about it, but it didn't show in the report. Okay. Do you want to add anything? Yeah.
And where it comes to, as sir asked us about selection of materials, while we were thinking about many ideas, we got to know like sugarcane bagasse, many more products like bricks, and even with sugarcane bagasse plates. And from all this inspiration, we want to make some other product with sugarcane bagasse, which is related to our project.
So it's a good thing. I mean, you used the right word, inspiration, there, right? But I think his question is more than saying if you're achieving 4 degrees less inside, how much of it is attributed to the material that you have selected? Even if I put my hand here, right, there will be some reduction through shading. How much of that do you attribute to this material?
So I'll take liberty of a minute. So I think I like the way you are thinking, but like he mentioned, if I would want to know why it is happening. You know, you are presuming a lot of things. That I have a good material, it will provide cooling. I have this, it will do. That's not how. If you are making a case, you have to actually go through why it's happening. So that's the element, and you know, like the numbers and a lot of things in the report. Why? And what, and so that makes it for example, if I'm saying a better cooling system, the energy use is lower. Why it's lower? Because I have better 5-star unit versus 3-star unit, right? Then you'll say, okay, because of that is happening. So that step is missing throughout. And I would encourage you to relook at the external shading device with the materials that you have. It would have a very important impact on the comfort as opposed to an internal shading device.
Don't give up on this. I think try and get it to market if you all can.
Okay, sir. So just a quick suggestion here, because you guys seem so enthusiastic about bagasse, and of course it's a great material. The tableware of bagasse are already in the market. So because you're using a pulping technology here, so one of the things you will have to keep in mind whilst using bagasse is something called depithing, because it has a lot of sugar in it. and that can, when you're doing something at scale, maybe in smaller volumes it might not be an issue, but at scale it can become bad really quickly, right? And that de-pithing is an additional cost that is there for the pulping, and you cannot just use mechanical pulping, I mean, out of the conventional pulping processes that we're aware of. So just the mechanical aspect might not, so think about if you can also improve how you are, doing the pulping process, maybe you can reduce something there, or, have an additional innovation there, that could be a good thing. So just something to think along those lines. Yeah, I'm done. Thank you very much, guys. And like he said, don't give up. It's a good product. So just think more on it.
Thank you.
Thank you. Thank
Thank
you,
you,
Team
everyone.
Swastika. Thank you. Thank you, jurors. Thank you for your comments. Okay, I'm hungry. I know you are too. So we're going to take a long break now, and we're going to come back with the fifth team, that's Team Solstice, at 2:30. So we will start the presentation at 2:30. So I recommend that you are here by 2:15 at the max. All right? Okay. See you in the afternoon. Hi, good afternoon everyone. Welcome back to Residential Cooling Retrofit Division of SDI Finals 2024. So it was very hot outside today, and it's good that we're going to hear more solutions for cooling. And we'll go ahead with our fifth team today. That's Team Solstice. Their product is named Terra Cool. Cool Earth, yeah, that's what we need. Team, please come. Yeah. Yeah. It's not there? I must have borrowed yours. Okay, hold on 1 second. So teams, you have a total of 20 minutes for your presentation to the jury. At the 15th minute, and there's 5 minutes remaining, I'll ring a bell once, and after 20th minute I will stop you. If you have not completed, I will stop you from continuing the presentation. You will not have a 21st minute. At the end of the presentation, you have 10 minutes for a question answer session with the jury. Okay? Right. So your time starts now.
Good afternoon, everyone. In the bustling streets of Delhi, the general person faces narrow streets, small housing, empty pockets, no ventilation, and crazy temperature and humidity variations. And this is especially capped during the summer solstice time. And this is where we, Team Solstice, come in as your best friend. For the first step of our design thinking process, we empathized with our stakeholders, who were the MIG and LIG households in Delhi NCR, and these included residents, workers, laborers, and their families. On an analysis of the user experience rating, although we can notice that there is an increase in the comfort levels as we go into the house, and this is with or without the presence of cooling appliances, still, a recent World Bank report shows us that temperatures are set to increase by up to 4 degrees in the next 100 years, and this will cross the human survivability limit. On an analysis of the temperature and humidity variations in Delhi, we can see vast variations, which means that an ideal solution should cater to all permutations of high and low temperature and humidity. User personas. For this, let's assume that I am the user. I'm 20 years old and I live in a tiny matchbox size apartment with 4 roommates. I make 40K a month, which means I can't really afford an air conditioner. But at the same time, a cooler is just not enough.
Yeah, and I'm another user. I've been living in Delhi for the past 20 years and I've seen myself living with the same water cooler inside my house. But recently we got an air conditioner in our house while we were renovating, and we figured out because all of our neighbors were actually getting an air conditioner, and we still end up using the same water cooler in our rooms because of the high cost of running the air conditioner. Yeah.
So the existing SWOTs of the products available in the market shows their pain and pleasure points. Ceiling fan, although cost effective, offers very limited cooling. Cooler, although still in the affordable range, has high water dependency, becomes redundant during certain climatic conditions, and has large space requirements. And finally, an air conditioner, although it offers the most cooling and space effectiveness among the three, it has high costs in its setup, maintenance, and working. So further, subsequently, we analyzed the pain and pleasure points of our stakeholders, which were as follows. These were their pain points, and these were the pleasure points we observed. And finally, this led us to identify their needs and most pressing requirements. And finally, our problem statement boils down to create an affordable and energy efficient cooling solution that effectively cools indoor spaces, requires minimum maintenance, and caters to the diverse user needs and environmental variations. Now, we have Anmol explaining us the ideation process.
So as we now starts towards the developing our product, we first started with material exploration. We first chose that we would be using evaporative cooling as a solution, and then we started what would be the ideal material, what desiccant could we use to improve for the humidity cases. We chose calcium chloride due to its ability that it can absorb 3 times more its weight, and another material we need to choose was the place at which evaporation will take place. Aspen wood could be a solution, cellulose based solutions could be there. However, terracotta based solutions stood out due to their higher conductivity, leading to more better distribution, as well as hygroscopicity, allowing for improved evaporation. Then we also chose there may be conditions of humidity or low humidity. And then finally, in the design process, we consider ergonomics. Where could we place a solution? Should it be near the door, or should it be near the window, or near the desktop? Where could it be? Based on those, we designed 3 possible solutions: a cooling pot, a horizontal vertical shaft, or a window-based cooling system. All of these had spots, and based on this, we did some testing. In the testing, we used a desiccant system initially, where we had desiccant running through the solution, and then we had evaporative cooling. And we were further very happy to see the results. We were getting a continuous drop of 5 to 10% relative humidity, a continuous drop in the testing. And another important thing was we were also getting a 4 to 5 degrees Celsius drop in the testing. The ambience was stimulated by high humidity and high temperature. In the upcoming section, we tested out, we finally chose terracotta window cooler based on multiple parameters. And after that, I would like my friend to further elaborate.
Right. So now we did the feasibility test of all the solutions all the ideations that we figured out, and we saw that the terracotta cooler was the one that was fitting the most parameters. And this is where we started detailing our final product, and we came up with the solution TerraCool. Now, this solution, we can actually place it on our windows for the best look and for the best function and the form aesthetics. Now what happens is we have direct evaporative cooling coming up from our windows, and at the same time, as soon as the humidity in the room rises, we can have indirect evaporative cooling happening. And at the same time, we can have a plug-and-play desiccant system or a box that can rightly attach below the system that can actually make the humidity in the room lower. And if someone figures out that they cannot have their windows customized to this particular solution, they can have a standalone system as well that could be placed right next to their windows. It just functions the same way. Now, when we are actually looking at how we can have this installation on our windows, we can see we can have steel frames over which we can have these railings, and within these we can have the terracotta jali or the terracotta bricks attached to them. The whole installation process or the way we designed the system is such that it can be opened up very easily, and the whole system can be modified or retrofit, or maybe can be cleaned easily over time. Now I'll quickly explain how this whole function works. In hot and dry climate, we have our upper terracotta system working, wherein we have the fan behind the terracotta tiles. Now, being the terracotta, it actually gives us an advantage of that extra 3 to 4 degrees margin than the existing solutions. Now, as soon as the humidity in the room starts to rise, the same water that's flowing in the terracotta can be now channelized to the evaporative coil. That's this section, which now acts as an indirect evaporative cooling. And below that, we can even have a desiccant box attached that can further helps us reduce the humidity inside our rooms. Now, third case, whether it's raining outside, the same system, since it's attached to the window. In a lot of these rooms in Delhi, we figured out that mechanical ventilation is something the people need. So the same system can also act as a mechanical ventilation, provide mechanical ventilation in our rooms. Now, in the above design, we chose out certain parameters and then we started testing them. And my friend will actually help you out on how we did what we did.
Okay, so to guide you through the prototype lab testing, first we started off by testing just the normal terracotta cooling system. So what we observed is a temperature drop till 31 degrees Celsius. Secondly, we tried to further optimize it, trying to play around with the jali opening size. So what we observed is we got further drop till 29 degrees Celsius. And then last we tried with attaching the paper pads to the terracotta jalis. So the idea behind this was to retain the water on the surface for a longer duration of time. And as expected, the reduction in the temperature was till 25 degrees Celsius. So, and one important thing here is the surface of the terracotta is normally very cool compared to the ambient. And this we found out using the thermal imaging camera. So the temperature that we observed was around 16 degrees Celsius for the surface of the terracotta, when the ambient was around 32, 33 degrees Celsius. So that's a significant drop. Okay, so coming to the cooling performance, here we tested two systems, one with desiccant and the other without the desiccant. So what we observed is, generally without the desiccant, the increase in the RH is quite significant. The relative humidity at the outlet increases if we use evaporative cooling. But with desiccant, the relative humidity does not increase a lot. And the temperature at the outlet remains constant. Traditionally, what should happen is the desiccant should increase the temperature, but that is not happening, what we observed. And coming back to the cooling performance, we observed a maximum cooling of about 8.5 degrees Celsius with our system. And this is our user testing, and the USP behind this is we incorporate the paper pads along with the terracotta, and as I mentioned before, it retains the water for a longer duration of time, giving us a significant drop in the temperature. And the energy efficiencies are improved, humidity reduction, as I said before. And another thing is the design of the entire system is very sleek, and it presents a very aesthetic appeal. So after doing all this, we compared our system with the existing systems in the market. So in case of installation and portability, we do understand that we require some technical manpower to install the systems on the windows. But if we want to incorporate a standalone system, that is relatively easy, and even the user can do it. And in terms of the space occupied, it's sleek compared to the bulky traditional coolers that are available. And the target markets that we first chose are LIGs and the MIGs. Okay, so these are some of the core benefits which I would like my colleague to just run through.
So reinstating, not only is our system energy efficient and budget friendly, it can also function during the monsoon periods, and it's a very sleek design, so it occupies minimum space, makes much less noise, and is made of sustainable recyclable terracotta material. On a life cycle analysis of terracotta, we noticed that not only does it increase the efficiency of a traditional cooler by 26%, it also leads to a 50% reduction in the raw materials if we incorporate recycling initiatives. This means that although terracotta has a significant embodied emission, it is still more than counteracted by the recycling initiatives. And moreover, as a future plan, we can also use the compressed stabilized earth bricks to which will reduce the cost of manufacturing, which will reduce the energy of manufacturing to 1/5 of its original value. And now back to Uttam.
Okay. Okay, so another thing what we can do in the future to reduce the embodied carbon for terracotta is we can use the solar clean process. Now I do understand that initially the initial cost will be quite high compared to the normal coal-fired plants where these are baked, but the operating cost will come down significantly as it's shown. So what we observe is the return on investment. It's almost the same for the normal process as well as the solar process. But on top of that, the advantage that we are getting here is that we can offset a carbon footprint of about 0.092 kgs of CO2 per kilogram of terracotta that we are firing using the solar clean. And these are the results and conclusions that I would like to show, that the reduction in temperature is about 25 to 27 degrees Celsius, as we have mentioned earlier, and lower running costs are there, and we see that the humidity and the temperatures are regulated well. So this is the go-to-market strategy that I would like my colleague to just run through.
So now, as we can see, we have versatility in our product, the way it's working.
we have the product. Now we also need to see how we can launch the same product into the markets. And looking at our TAM size, we could see our immediate TAM size being the 2 to 4 CR based on our Delhi NCR population criteria. And the existing channels, how are we seeing is this, we can actually look at existing channels or distribution networks that the AC or the cooler vendors have and can channelize the same. Apart from that, if we want to have our coolers installed on the windows, we can even have the UPVC vendors in the market and can actually ask them, maybe they can customize one of their panels as a solution. And looking at our market strategies further, we can see we can create a value proposition wherein by word of mouth or through exhibitions, we can actually tell the people what the value our product can make. And secondly, maybe we can also look at digital marketing campaigns. Further, looking at our business matrix, we figured out now we have a value proposition and we have a customer segment being the residential. We figured out in what all ways can we earn. By upfront selling our product, we can have a revenue generation. By installation services, we can generate revenue. And then maybe in the after sale services, basically in terms of warranties or APM. We also thought of a system wherein maybe we can have a swap-in mechanism wherein the bricks can be swapped over time, or even, for example, if today it rained so much and you have a dehumidifier, that plug-and-play system, which is of no use maybe by the end of the day, you can even have it swapped by the next day if it rains again. So swapping mechanism could actually help, and also help the same mechanism clean better into the factory quality check system. And in the cost structure, we figured out various parameters, and my colleague will actually detail it further.
Okay, so coming down to the unit economics, if we run through a simple calculation, considering the price of the brick for around 28 rupees, considering 15 bricks are required for one normal Jali window, we get around 420, and adding the fans and electronics, 2400 for that, and frames and structures come around 1300. So adding labors and transportations, our total manufacturing estimate comes around 5890. Okay, so with a minimal marketing expense of around 400 roughly, we can deliver the product in around 6290. And considering the price point to be around 10,000 to 14,000 rupees, which is backed by the survey we conducted, the users are willing to pay for that. So we get a gross margin of about 3710 to 7710. That's a gross margin we can achieve. And so before that, I would like to request my colleague to just demonstrate the product.
Right. As we can also see, we have versatility. We can even automate the whole system. We actually tried developing automation through our sensors, wherein it can identify that the humidity in the room is increasing. It can quickly change the modes, and maybe we can always change between the direct evaporative cooling to indirect evaporative cooling. You can have it in a system wherein you can actually make the dehumidification palette work, and we want to similarly experiment the same.
So here's a basic proof of concept. When we have these fans placed behind, it goes to the desiccant. Here we have placed desiccant, which removes humidity from the air, and then it passes through bricks. We have already poured some water over the bricks so that it reduces the temperature over time. And here we have a thermal sensor which will show us the temperature of the bricks. I just clicked a photograph a minute back, a few minutes.
Right, so at present itself, it's at 12 degrees temperature. And when we were experimenting outside, it was at 16 degrees. So in all of our experiments, we were able to achieve it to a minimum of 14 degrees of the terracotta, and the water can be cooled down to 16 degrees temperature in our experiment.
I will just get a pic of it and show to you that the temperature has reached 12 degrees Celsius for this bricks, 12 to 13 degrees Celsius approximately. And this proves the concept that we have a 7-degree reduction in the temperature right away without much of the distribution which would be present in the actual product.
And this is how we were able to get the whole temperature down from 30 on an average. Like in Ant Studio case, they were able to get it down to 30 because of our system. So our USP with the use of the paper, we were able to get it down to 25 to 27 degrees temperature. There we rest the case, and thank you. Is this working?
It's okay. It's okay. Yeah, it's okay.
This is the temperature. I just clicked the photograph a few minutes back. it shows 13.7 degrees Celsius for the bricks and ambient temperature of 20 degrees Celsius at that moment because the doors were open, everyone was coming in. And
So that's it. Thank you so much for your time.
Thank you. Thank you very much. Over to the jury. Microphone is behind you. Kshitij.
Have to start? Okay. Thank you, team. I like your idea exploration that you've done. I think you all should have spent a little bit more time on that. Could have come up with good ideas in there. So good job on that. I also appreciate the fact that you've actually taken time out to walk us through the demo and at least made an attempt to see how it works and all those things and showing the temperature difference. So good work on that. Your target audience that you're talking about is a 1 BHK, right? And all the photographs that you all showed, I don't know if you all observed that, there's just one window, of which 50% is gone in this installation. What is your view of customers or users? Did you talk to them about this?
Yes, sir. In our interviews itself, we were able to see that a lot of these customers were actually having summer coolers placed while in the summers, whereas in the winters only they were actually removing the same. So in our system as well, when it's a standalone system, it's easy to move it around. In the winters, we do not want the outside air to come in, but at the same time, we want some sort of sunlight. But sunlight is not at all that sufficient when we are talking to our customers. That are you able to actually perceive the?
But
sunlight?
you're blocking light, right?
So, right? So in order to make a barrier from the outside to inside in winters, we can have a sliding mechanism or a shutter installed into a system that can make a barrier from the outside to inside. Half of the window is already, so that's where we said if you have only one window, maybe you buy a standalone, because that's what we'll propose you to do. But for someone who can have two windows and he also has an air conditioner, and he says the running cost is so high, he can also have our product installed as a panel in their system and can have the same thing used.
Okay. You made two more points in there. I made a note of that. One is the hostel students.
Yes.
I'm glad you're thinking of that. Any of you live in the hostel? Okay, there you go. That explains it. They're the right users, but I think the buyer is somebody else. I think you all need to think about who the eventual buyer is. I don't think the hostel students will ever buy something like that and install it. Just a suggestion. I might be wrong. You all might have a different view on that.
The stakeholders in the college will be the ones who will be funding.
Yes, the college facility management will have to install it, right?
Yes, yes.
Yeah.
And all the more we're allowed standalone installations in our room, so we can purchase that one. And I guess this is a common viewpoint. We will be willing to spend 10 to 15,000 if we can get that much comfort.
Okay, cool. Also, another point was anything for comfort, right? Today.
Yes.
I think you'll need to focus a little bit on where your revenues are coming from. It's okay to say it's going to be only product sales, and nothing wrong in saying so. By doing the other things that you are trying to do, right? For example, installation services, it's okay if you don't do it. It's like saying penny wise, pound foolish. So stay focused on your product sales, and I think you all should be able to get through.
Yeah, we are primarily focusing on product sales. However, we would be offering a standard annual maintenance service charges and other these bricks would be approximately replaced in 2 years or would be cleaned, so that those kinds of services would be required when we make another revenue stream. Major stream is product upfront upfront.
My last suggestion, while you all have done the research on LIG and MIG, right, and the houses that you all have went to, that has inspired you to come up with this kind of a solution. Now, it's not necessary that you have to go back to the same segment. Please do spend some time thinking of where this will be applicable, right? It might open up a new market. It might open up a new, completely different segment altogether, and that's okay. Yeah,
So
just a suggestion.
Interestingly, while we were having lunch here, we felt like this kind of open space might require a cooling system when we can integrate such system because it blends in with the place and we can have a much more energy efficient system. Like here itself, when you have an open place, you can have such kind of wall placed and then there's a water dripping. It would be aesthetic as well and bring about some cooling in these open spaces.
Also for architects and designers, maybe the way they have their WCs placed in the bathrooms, maybe they can even have the same system installed in the windows itself, wherein they can actually conceal the water tank down below and then can actually, so one can actually look into all those segments as well. You can have a product designed for architects.
I'm glad you're talking about that. Now you're actually thinking. This thinking should have gone when you were thinking about the product earlier, and it's a good idea. So that's what I'm saying, right? It doesn't necessarily have to be on the window as well.
Yeah.
If your product is, it's allowing to cool that air around it. It can be somewhere else, and that's okay.
We wanted natural ventilation, natural air coming from outside inside is better. So placing it at a threshold is much more efficient and better than having it inside and working standalone.
Okay.
So placing it near to a window is always an advantage.
Great, great. That's great. Good job with the presentation, and especially after lunch, so well done. Just quick question. I mean, he's covered a couple of points that I wanted to. Just one question here about your regeneration ability of calcium chloride. And so you mentioned that you're going to be using that, and who's going to keep on providing it? Like, it shouldn't be the user's responsibility to, keep on maintaining the dehumidifier.
That's where we are having a swapping system, because quality control checks can only be done at a factory setting in our system. For example, we have the electrical
No,
battery.
say like I buy this product, and
Yes.
do you give me the solutions, and when do I run out of it, and would you provide it again? So it's a recurring cost for me.
So one can easily regenerate the same by placing it into the sunlight. Yeah, but
while we were designing the desiccant solution, one of the major thing we concerned was with regeneration part, and we actually found that solar was able to regenerate to a bit, to a great extent, to be precise. We had around 20 gram of desiccant. It absorbed around 7 grams and reached 28 grams of the weight, and in about an hour we got it back to 23 grams using solar. So what we are thinking is using of liquid desiccant, because it acts as a storehouse for, we can recharge it during the day, and then it may be reused during the whole of the time. That's a specialty of liquid desiccants, wherein we would be majorly
So you're
dealing
going
with.
to be looking into another system which can be more sustainable and have a longer
Yeah.
shelf life that
Yeah.
way. Yeah, and so just to touch upon your financials here. So, in the financials, you sort of breeze through like, okay, labor cost is 150 rupees, and, this is going to cost you, I think, 3,000 rupees for our shelf panels and everything. Now, the total cost you came up with is 5,890 rupees. Is this the cost of just producing one unit? Did you think about how the manufacturing cost would be if you were to produce, say, 10 units, 20 units and scale up? What is the costing going to look like then? The logistics and transport and everything are quite variable. So did you guys also think through your tangible costings that will come into the picture, and then base your final sales price, because the final sales price is almost 5,000 more than what your manufacturing cost is. So what made you think of having 5,000 rupees more margin?
So, ma'am, our price came up from the survey that the people would be willing to pay as per the value proposition they are getting. So that was around 12 to 15K that we figured out. Now also, while coming up with so making one device was actually expensive, that we also figured out. But when we were writing those, we actually figured out when we scale them, maybe 2,000 or 10,000, we would be able to cut down on the cost significantly.
So this 5,890 is for how many units produced?
So producing the single unit is costing us around 5,890. So when we scale up, it's obviously going to go down. So this is the maximum cost that we are trying to project.
So you will think about
even
the
at the
scale up,
maximum
yeah.
cost incurred, we are having a gross revenue that's quite.
Yeah.
We are paying taxes.
Yeah.
We are paying marks to all that. When we are buying products just for one, it actually gets higher.
Okay. And I did want to know, just, you mentioned Ant Studio in the end, and, I'm sure you probably have heard it before. Ant Studio already has a product like this. What is your novelty here?
So the desiccant system, as we said, is our novelty here. And additionally, we are using paper pads as well, along with the terracotta jalis. So the Ant Studio, they don't use that. So with that, we have more water retention and the temperature
But
drop
I'm
is
just going to
significant.
give it to Yash now, and I think he can sort of build on this.
So, before I start, I want to kind of, have an observation, two observations. One is what we saw in the report versus what in the presentation. There is a huge difference. So I would encourage you, when we come prepared, to not
even if you have done more work, you present it in a way that this is additional work done after that, because that's not fair to everybody else. So that's one observation. The second observation is, it to me, when I see these things, I think it's a fantastic. I'm very, very happy that you took on this challenging problem. Evaporative cooling with dehumidification is a holy grail. You know, if you can solve it, that's like nothing like that. So it's a very important area to work on. But to me, when I look at these solutions, I feel like you have to go back and rehash your product design, because it seems like you have stuck with one and you are adding another components. Now you are talking about another, dehumidification system, and now you're saying we need liquid because it's can solve, because recharging is an issue. To increase the efficiency, you are adding the pads, the fan, the location. So to me, when I look at that solution, it needs it always happens in the solutions that you go back and then start saying, because essentially what you have right now is a if I technically, from my perspective, see dehumidifier, which needs to be recharged frequently, more frequently than you are making it sound. Trust me on that. It will become more and more challenging as you operate it more and more hours, because dehumidification is one of the most challenging place. Because of that, your cooler efficiency will go down, and cooler efficiency in the numbers of the temperature is not really reliable, because you are measuring using an emisometer where emissivity is assuming of the material, which does not work in the wet terracotta surface. So that you need to relook at some of the measurements of the numbers, and then look at the products. I am seeing a potential. I'm seeing that it's a good solution, but I'm suggesting you to relook at.
Sir, I guess there's some misconception. Dehumidifier is not a direct parameter to our cooler. It's like an add-on. In humidity times, we are saying our cooler provides mechanical ventilation to your room.
Correct. See, there are lots of issues when you talk about mechanical ventilation from outside. You need to add a filtration in a city like Delhi. If you don't have, you are bringing particulate matter in. And so I don't want to debate, but all I'm trying to suggest you is that these are very good thought processes and add-ons that, as you are finding out a problem, you're trying to find a solution to it. But this is a good time to go back and start saying, okay, do we really, because essentially what you have is a dehumidifier with a evaporative cooler. Whether indirect really adds a value or not is a questionable. The temperature values are questionable, frankly. And the other numbers also, sorry, I lost my train of thought on the thermal mass of terracotta is actually giving you a huge benefit. So that's an element of thermal mass which stores water, and dampness gives you certain elements. So instantaneous measurement will not help you assess the actual performance to be able to improve the product, is what I'm trying to tell you. You need to look at it a longer duration. So that's a feedback. You don't have to respond to that, but good job, guys.
Thank you. Thank you.
Sorry, one more thing, just want to add to that, to what Yash said, right? You're solving multiple problems, and I can see that genuine effort going in. I think you need to get to the next stage, given the amount of time that you'll have and where you are today, right? You've done a fair job, good job. Think of it as a solution, right? This is a set of multiple ideas that have come together, and it's still raw, and I get it. But next step, think of it as a solution for the end customer. It's not there yet today. Yeah.
Okay,
Cool.
thank
Thanks.
you. Thank you, jurors. Yeah.
Sure.
Thank you. Thank you so much.
Thank you.
Team Solstice. So we'll be back with the sixth presentation after a short 5-minute break. Okay, so our sixth team presenting today is Team Tejasvi. So they have worked on a Cool Guard security cabinet. Team Tejasvi, yeah, please take the stage.
Double click it.
Okay. So team, you have 20 minutes to present your presentation to the jury. At the 15th minute, I will ring a bell to let you know you have 5 minutes left. You will not have a 21st minute. At 20th minute, if you have not completed, I will stop your presentation. After that, you have a 10-minute session with the jury for question and answers. Okay? Right, so your time starts now.
Good afternoon to all the jury members and everyone present here. We are Team Tejasvi of engineers and an architect. I am Mehak Gupta
I am Sukhsahaj Singh.
and we are presenting to you to our climate bliss cabin. Okay. This is our team. Climate Bliss cabin is specially designed for a security guard and is a vision of vibrant team of future energy efficient cabin. Our primary goal is to use our retrofitting devices, that is thermoelectrical module, for human comfort. Till now it has been used for many devices like refrigerators and VCRs, etc. The main reason that led us to this topic of concern was rising temperature, uncomfortable conditions, especially in summers, which leads to discomfort, heavy sweating, lack of work performance, efficiency, and alertness. So to overcome this problem, we have come up with a solution of thermoelectrical cooling, which is designed for human comfort, provides comfortable temperature, and also have easy installation and off-grid solar power.
So conventionally, we were using VCRS system, vapor compression refrigeration system, which includes four main components, which are compressor, condensation, expansion valve, and evaporator. Evaporator is where we get the main cooling effect. So this VCRS system has many complex and moving parts. Also, the refrigerants used in these systems are harmful for the environment. They deplete the ozone layer and contribute to the global warming. Also, the power consumption is very high. It is around 500 watts to 1500 watts according to the size of the AC. So this is basically the normal AC which we use in the households. The noise of the compressor is so much high that it creates disturbance for the humans as well as other creatures. Here is a chart of the global warming potential con contribution of the different refrigerants. As you can see, these are very high values, and these also the ozone depletion potential is very high for all of these. There are some of the refrigerants which have less global warming potential, but the ozone depletion potential for that refrigerant is also high. Now, why we are moving towards the solid state refrigeration?
we have taken this idea from the automobile. There, these solid state refrigeration is used to cool foods or cans. So the solid state refrigeration system is basically has no moving parts. We can use it for spot cooling. It has ability to heat and cool both at the same time. Also, this solid state refrigeration uses less electricity as compared to the VCRS or other conventional system. Also, this solid state refrigeration system does not deplete the ozone. The thermoelectric module, the solid state refrigeration system, basically works on the Peltier effect. We have a semiconductor. When we provide a DC current to the junctions, there is creation of two ends. One is the hot end and other is the cold end. And we are using the cold end to provide the comfort cooling in our cabin.
Security guard rooms are available in all types of buildings like residential, official, commercial, educational, etc. These are small enclosed spaces which can become very uncomfortable and hot, especially during summers, and impact guards' well-being and their ability to perform. So by providing the solution to this problem, we have come up with a solution of climate bliss cabin. It is designed to provide comfortable temperature, solid state cooling, full off-grid operation using solar power, sustainable choices, easy installation, insulation from surface heat, solar panels for shading and providing power, minimal upkeep, and is also very customizable according to its user.
So we generated a prototype for the idea, so which consists of two thermoelectric modules, and we have also connected a battery and a solar panel. The solar panel was 180 watt and the battery was 65 ampere hour battery. We use battery to power the modules and solar panel were used to charge the battery. And we used two different temperature sensors to detect the outside temperature and inside temperature to compare both the to get the delta T. So without any insulation or any other uh, insulation, we have achieved a maximum of 5.5 degrees Celsius of delta T. And the power consumption was very less. It was only 66 watts for the two modules in total, and which is also very less as compared to the VCRS system. Here we can see the charts of the temperature difference and the inside or outside temperature. Also, we tested the battery, we noted the battery discharging rate and the battery charging with solar. In battery discharging, only around 0.7 to 0.6 volts was reduced in over the period of 4 hours. And we also noted the battery charging with the solar power while simultaneously running the modules. And we regained the recharge the battery from 12.2 to around 13, which is full, which means the battery is fully charged in only 30 to 40 minutes. Also, for the insulation, what we can do is we can incorporate the inert gas windows in our security cabin, which reduces around 90% heat from the outside to come to get it through inside. And also we can use for the walls, we can accommodate PCM material, which is phase change material, which usually converts on the basis converts its phase on the base of its temperature, basically like solid to liquid or liquid to gas, while absorbing or releasing the heat. Also, we can incorporate in our cabin that the geothermal cooling pipe. We can dig deep inside, like 3 to 4 meters inside the earth, and use a simple fan to cool the air through and let it through the pipe, so we can get a cool air for the cabin. It has some co-benefits, other benefits also. Like in coastal area or where there is high humidity, we can fetch potable water using these modules. Also, as you know, these are working on pellet effect, so the operation is all weather. We can use it for heating purposes also in winter and cooling in summers. Also, we can accommodate larger size modules to use for localized cooling in a office room or in a household. For like the area of the bed only, we can use to cool the area there. Also, we thought of this concept like from the mythical refrigerator, that we for hot and dry areas we can create a clay outside wall of clay and insert mix it with the dry grass, so that dry grass can act as a capillary. And for with that we can this is basically the evaporative cooling method. The thermoelectric module has been is being used for the foods and storing foods, vaccine and cosmetics, and now we are using it for the retrofit purposes for human comfort.
Now coming to the marketing strategies, the single unit of this cabin can cost up to 22,900 Indian rupees. So firstly, we'll look for a target audience for the marketing and identify the demographic and psychographic and the behavior pattern. Then accordingly highlighting the product advantages. Then we'll market it by creating content like blogs, articles, and also using social media as like our medium to reach out. We'll showcase our module slash prototype at at relevant trade shows, expos, and offering responsive support channels and analyzing data and taking the customer's feedback as well. Thank you.
Thank you for the presentation, Team Tejasvi. Jury, over to you.
Thank you for the presentation, guys, and good thinking. Definitely very good thinking, and I like that how you also included different types of innovation in there, and I think you can think through that and build on those as well, like your pipes that can come from the ground and a couple of things there. So I would start by so a couple of things I would like to mention here as well. You're achieving a 5-degree reduction in 105 minutes, right? And after that, is it maintained? Because when you're talking about a security cabin, now a security guard is not stationary, right? And the security guard is always moving. So how would a cabin like this is going to benefit? Have you guys thought about other user case studies and other target market, wherein maybe there could be, other people who could use this as a retrofit? Because when you mention about security guard, their shifts, they're moving around. I'm not quite sure how it would directly help them. So that's one thing. And the second thing is that the solar post processing of it, because you've mentioned that the traditional because you were giving a comparison, the traditional ACs and they're environmentally not very friendly. But the post-processing of solar or TECs is also a little tricky and has a huge impact on the environment. So that is something to think about. Lastly, because the security guard cabin and you're promoting it as such, have you heard of these cooling vests that security guards can wear, and which is more portable and affordable as well? So if the solution is already there for the security guard, what would this panel do for them?
So ma'am, the first question was like, can it maintain that temperature difference? It will like slowly come down, like slowly increase the temperature difference, but we are just focusing on the comfort cooling of the for like humanitarian purposes to provide a comfort cooling to the security guard. So it can assure like if we open the door and again closes, it will achieve that temperature difference also. Also, it will be easily achieved if we will provide the insulation and all that. But here we have not used insulation, so we can easily achieve more temperature
In the
difference.
later stages, you can
Yes.
think about the insulation. You're saying
Yes,
that
ma'am.
it could be more efficient.
Yes, ma'am. So the next was that we can incorporate it into like any small places, small cabins, or like in we can use it in tractor cabinets also. Like that is like pretty much one cabinet, only small cabinet. We can use it there also. And the third was the cooling vests, which are like for the security guard. So they are basically the PCM material which they are using in that. But in like area like for the traffic police force, they have given like small cabinets for that. For so we are basically focusing like where the security guard sits and whole day, and we can use that. This residential retrofit there.
Okay. And sorry, before I give it to the other judges, just a quick touch on, your revenue model here. So you're pricing it at 20,500 rupees. What is your target? Who's your end user, right? Because a security guard, I'm not sure, is going to invest in that. So what is your go-to market strategy, that you've lined up?
Yes, ma'am. So basically, our product is B2B, not directly a security guard will be investing in it, but buildings like educational building, residences, or any office building, they need a security guard, and then they'll be providing their a cabin. So they'll be providing these types of cabin, and even government can also use like for the uh, traffic police person, they can provide this in their cabin, so that in summers they feel really hot and they can like get comfortable at least during their break.
Okay, okay. Good thinking, though. Very good thinking.
Thank
Well
you.
done, guys.
So thank you. So good job on, I think, a couple of your slides. I really liked. I think you've done the best job in being able to communicate and showcase the empathy and sensitivity for the segment that you're trying to solve the problem for the security guards. So well done on that. Very, very well done. But I'm just curious, why did you all choose this path? Like, why the security guard? I mean, it's a slight deviation from the core brief, but why?
It's not just about security guard. Like I just said, it can be used for traffic police person also. Like they are really like working very hard during the summers, and they are continuously standing outside, and we can see that they are sweating all the time. So just the idea just came in that why not, if we are providing something, why not just to provide it to those who really need it. Like in houses we can like we already have our ACs and everything, but they really don't have anything. So why not, if we are doing, why not creating awareness in these things?
So one more point. We because the security guard cabinet is very versatile. We can see it almost everywhere around here. Around the Infosys campus border, we have seen like security guard sitting there. Also, sir, it can be like fully off grid. Also, we are using the solar power to use power it. So we thought that it would be a good product like that we can introduce.
Okay, no, you're solving a good problem, so no doubt on that. But who's the buyer? I mean, you said it's the institution, government. Okay, if they are your buyers, what is your value proposition?
So basically, so we are not like, for now we have provided the like 22,900 budget, but obviously when we'll produce it in bulk, then we'll purchase the products in bulk, and we'll have the costing also less. So the amount will definitely go to one, like 3/4 less than this, and the amount will be only 1/4 of it. So yes, the like residences, or so they can buy and they can install these for the security guard for their efficiency, work efficiency.
So all your points are valid. So you can reduce the price when you do bulk manufacturing, right? But if a government agency has to buy it, let's say the Bangalore Traffic Police or the Mumbai Traffic Police have to buy what 1,000 to put it across the city. What is the value that they will be looking for? Or let's say this campus that you are in, they need to procure 50. Who's the buyer here? And what is the buyer looking for? And that's my question. What is the value that you're providing to that buyer? I completely understand the benefits that the security person is getting, and you've solved that problem, no doubt on that. At least that would I like to believe. I mean, the cooling part, I'll defer it to Yash to comment on that. You got my question, right?
Yes. So basically, we are not like very good in the marketing, uh, but we can say that for this, like they need to provide the comfort to like so they can work easily and in better environment. So they have to buy that to accommodate
No.
the place for the security guard and
Let's hope the security guard doesn't sleep inside because it's so
Yeah.
comfortable
Sir,
now. But that
sir-
poor fellow will lose his job then because of it.
Sir, we are not providing that much cooling here, only a comfort. So he doesn't sweat and
So we are not making the environment cozy inside. We are just providing it the sufficient amount of cooling so that the person cannot like feel
So-
a
so-
little bit great.
Building on that point, I think it will be important to differentiate between heat stress, it's saving from heat stress versus thermal comfort. So some of your temperature numbers you need to, verify that whether you are saving from heat stress or that. The second few observations for, you don't have to respond very quickly. I'll just summarize what my observations are. One is, often those doors are open of the security guards. And so if you have a double glazed windows, or the PCM, often it becomes irrelevant because now you have a air moving in.
Yes,
So you might want to have shading that will not work for the security guard because they have to keep an eye. So that I think is an aspect you may need to relook at.
Yes.
The other point, which is, fundamentally you need to relook at the solution because you need to get into what is the heat load needs of the space. You're talking about 66 watts. Now, efficiency of these units at the best is 100% versus the traditional vapor compression gives you COP of 3.5 to 5, which is 350 to 500 times. So you are talking about, you mentioned it's more efficient, but actually it's
Yes, sir.
1/5 of the efficiency. That I think. Then solar panel and thermoelectric module is inverse of each other. If you look at the physics principle, so you are, basically you are doing the inverse
Yes,
of
sir.
that,
See,
right?
but
So you
we
have to,
can sit
so
and
that there is a
practice
net electricity loss, right? So that you need to account for. Third, the temperature numbers are little worrisome because you are not rejecting heat outside. So thermoelectric side has one side as a cooling, other side as a heating.
Yeah.
In the same space. I know you've attached to the ceiling, but if you are rejecting heat in the same space, the net cooling cannot come. You know what I'm saying, right? Because you are saying heat from here from Kshitij and putting it to me, the net is still not have a negative number. So there are some things you may need to relook at fundamentally.
Yes.
I would encourage you to rehash the entire problem and look at the security cabin. That's a important area, but maybe address it from heat stress point of view. Think about how they are connected to the outdoors. And I know that you want to keep it grid independent, but something which is a little bit more viable in terms of the for example, security cabin has to mostly work in the night. Now you don't have solar panels. Now how much are you going to charge the battery and what is the impact of that? So, those are the things you need to look into.
Okay, thank you.
Thank you, sir,
Thank
for
you,
the
jurors.
feedback.
Yes. Thank you, Team Tejasvi.
Thank you, sir.
You can take your seats. Thank you. Okay, so that brings us to the end of Residential Cooling Retrofit Division. Jury members, thank you so much for spending the entire day with us, for all the comments, to all the finalists, and all the finalists present here. Congratulations once again. So as a jury coordinator for division, I've had the opportunity to see these teams submit all their reports, and they've done some incredible work. 9 months, this is absolutely great, and that's a consensus we have had throughout our deliverable process. And let's also not forget that, you know, the teams have, all of you have done this in addition to your regular studies also. So congratulations on that, and a round of applause for yourself. Very well done, guys, very well done. So this evening the jury members will meet, and they'll decide the winner and the runner-up teams. And while we wait, don't forget to head out to our YouTube channel and vote for your favorite movie. All right. And we have an exhibition called the Climate Smart Innovation Exhibition, where you get to see innovative building products from the industry that address climate change. So the exhibition is open for you, and that is being held at the multiplex zone, which is just 5 minutes from here. And if you get lost, you can use the QR code on the back of your ID to get the Google Maps locations. And for people who are online, stay tuned to our channel at 6 p.m. You can watch the 10 exhibitors from the Climate Smart Innovation to pitch their products to win the Climate Smart Innovation Award. Until then, have a great evening.